Hey everyone, welcome to our advanced MongoDB full course by Simplilearn. In this comprehensive full course, we will delve into the depths of MongoDB, a powerful NoSQL database, and explore its advanced features and functionalities. Whether you're a seasoned developer or a curious learner, this full course is designed to equip you with the skills to master complex data modeling, advanced querying, indexing, sharding, aggregation, and much more. The course will contain the MongoDB basics, regular expressions in MongoDB, aggregation in MongoDB, sharding relationships, GridFS, MapReduce in MongoDB, projection, MongoDB Replica Set, database references, Python MongoDB, indexing in MongoDB, cluster operations in MongoDB, and finally, Java connectivity using MongoDB. So without further ado, let's get started. If these are the type of videos you'd like to watch, then hit the subscribe button, like and press on the bell icon to never miss on our future content. Also, if you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who likes to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM. The link in the description box and the comment section should navigate you to the homepage where you can find the complete overview of the program being offered. Now, over to our training experts.
Alright, so what is data modeling in MongoDB? Now, basically, data modeling is a process of taking unstructured data that is generated from the real world scenario and introducing it to the data server and then structuring it into a logical data model in our database. So it is basically a process of determining how data is stored and what connection exists between various entities in a relationship. Now, you don't have to create a schema before inserting data because NoSQL is flexible. This is so that MongoDB can support a dynamic database schema that makes it unnecessary to create your schema in advance. Instead, you can now store your information and make changes in accordance with your data. Now, consider data modeling in MongoDB as a relationship. Now, there is no particular relationship just like SQL where we use. Now, MongoDB relationships are the representations of how multiple documents are logically connected to each other in MongoDB. Now, since MongoDB is a document database, any document within the same collection is not mandatory. To have same set of fields or structure, you can store different types in a collections given field and can even add new fields, update fields, and delete existing fields as well. Now, for example, consider an online shopping store where we have like thousands of customers arriving daily and purchasing new products from the website. Now we get a lot of unstructured data, that is the name of the customer, their details and all, which is basically an unstructured data. Now, in order to convert into a proper structured data, we need to model them into a particular way. Which this is where data modeling comes into a picture, where we store the data based upon our requirement. Now, the main challenge in data modeling is balancing the application needs, guys. Now, the database engine's performance characteristics and also the data retrieval patterns. Alright, let us now move ahead and understand why we use data modeling. Now, data model basically helps us to create a simplified and optimized logical database that eliminates redundancy, reduces storage requirements, and enables efficient retrieval from the database. Now, data modeling may appear to be a complex process wherein you have to make adjustments to your database, unlike SQL where you predefine your schema and create a new table and then store the data. Now, while in MongoDB, data modeling helps us to analyze and understand what type of data and how much data has to be inserted into a database. Data modeling is necessary foundational work that allows data to be stored more easily in the database and has a positive impact on data analytics as well. Now, let us understand why exactly we use now data modeling. Now, data quality is paramount for any organization, and to ensure that we need higher data quality when we are storing unstructured data in large amounts. Now, the visual representation of requirements and the business rules enables to anticipate what could lead to a large-scale data corruption before it occurs. So, data model enables the developers in hindsight to define rules that monitor the data quality and ensuring that there is no possibility of errors. Now, it is also important to understand how the data is flowing within the database and the characteristics of that. Creating data models forces the business to define how data is generated and moved across the application. Development and maintenance. Data modeling exposes errors and inconsistencies early in the process, making it easier and less expensive to fix. So in order to maintain a database that is a MongoDB database, which is basically an unstructured one, it is important that we try to develop and maintain it in a regular basis. And finally, performance is another reason why we use data modeling. Now, an organized database is one that is more efficiently operated, and data modeling prevents the schema from endless searching and returns results more quickly. Those were some of the reasons on why we use data modeling, guys. Alright, let us now move ahead and discuss how data modeling works in MongoDB. Now, unlike SQL databases where you must determine and declare a table schema before inserting data or perform any operations, we need to basically provide a schema for that. Now, MongoDB's collection by default do not require the documents to have the same schema. Now, the documents in a single collection do not need to have the same set of fields, and the data type for a field can differ across documents within a collection. Now, to change the structure of the document in a collection, such as adding a new field or removing the existing field in a document or changing the field values to a new type or update the documents to the new structure. Now, basically the first step is to basically create and design a schema as per the requirement and the application need by the user. And then we have to combine documents. Now, if there is no scope for multiple documents to store into a single one, and ensure that if there is no other need for a single document to store in a multiple document, in such way we need to understand what is our requirement and combine the documents accordingly so that we can have performance as well as the optimization of the database is also improved. Now, this flexibility facilitates the mapping of documents to an entity or an object. Now, each document can match the data field of a represented ID entity even if the document has substantial variation from other documents in the collection. So this is how basically a data model works, wherein you have to choose as per the requirement and understand what type of documents that are being inserted into the database. Alright, let us now understand some data models that are used in MongoDB. Now, once you've understood the business requirement and the application on how it should be, as you start modeling your data, you will likely go through various steps of data analysis. Now, each step might produce different types of data models. Therefore, ensuring data models having the right one can be generally thought of as being one of the main aspect of choosing a data model, and they are conceptualized into three categories based on the level of the detail and the specificity. Now, they are classified into three types. The first one is conceptual data model. The conceptual data model explains what the system should contain with regard to and how it is related. This model is usually built with the help of the user and the stakeholders. It represents the application's business logic and is often used as the basis for one or more following model. Next, we have the logical data model. Now, the logical data model will describe how the data will be structured. In this model, the relationship between the entities is established at a high level. You'll also list the attributes for the entities represented in this model. And finally, we have the physical data model, guys. The physical data model represents how the data will be stored in a specific database. Now, in this case, we have MongoDB model where we are establishing a primary and a secondary relationship between the data in a document that is stored in the database such as MongoDB. You will also establish the data types for each of your fields that are mentioned. This will provide you with your database schema as well. Now, although MongoDB has a flexible schema, you need to data model or schema design. A good data model means that you'll establish a strong foundation for an ever-evolving data model. Now, MongoDB supports multiple ways to model relationship between the entities in a data model. Now, the first one is one-to-one. That is, in this type, one value is associated with only one document. That is, it will have a single relationship between the two connected objects or entities in the database. Next, we have one-to-many. Here, one value can be associated with more than one document or value at the same time. And finally, we have many-to-many. Now, when two or more entities within a document can have multiple relationship, that is basically is many-to-many relationship. In this type of model, multiple documents can be associated with each other. So let us now quickly understand with an example. Now consider the example for one-to-one relationship where I have a student table and contact info table. Now for each student ID, there is a unique details or the contact info. So it is basically pointing one value to another. That is student ID, which is one-to-one relation. And similarly, we have one-to-many relation wherein we have customer table and orders table. Now, every customer has a different ID and a customer can place multiple orders. So it can generate multiple order IDs. So we have three different IDs like B204, B391, B448. So this is what is one-to-many, which is basically one entity is being pointed to three other values. I hope you understood one-to-one and one-to-many. So if you understood this, let us know in the comment section below what will be a good example of many-to-many relationship. Alright, moving ahead, let us now discuss the types of methods to create the data models. Now, once we are confirmed with what data model we need and the relationship that we have chosen for a documents to store the data, we need a method that is to create a data model. Now, that is where we have two different data models that stores the data in documents. That is, first one is embedded data model. So in embedded data model, you can embed data in a single document or structure in MongoDB. It is also referred to as denormalized data model. It leverages the full potential of MongoDB's rich document and it uses one-to-one or one-to-many relationship, guys. Next, we have the reference data model, or in other words, it is known as normalized data model. Now, they are used to build one-to-many as well as many-to-many relationship models. Now, while working with the embedded document models, there will be times when you have to repeat the data. This is where reference data model comes into picture, which basically tackles the data redundancy. So I know it is a bit of confusing, so let's just understand this with an example here. Now, if you consider the embedded model, if you look at a document which I have taken here, which is the details of a student named Rohan, where we have a collection that is containing a document has Rohan. In this document, we have embedded a document here that is contact details and his grade. So embedding data model stores relevant details in the same documents or the same database record. This way you can minimize queries and update required to perform common database operation. On the other hand, we have a reference data model or the normalized data model. So if you look at to the reference model example here, we have basically split a single document into three documents, and since contact details and grade have the ID from the document that is of Rohan's, you can call them whenever needed. Now, normalized data model splits the data into multiple collections by using references between the newer collections. You can update or change a single document which will update other collections automatically. This is an efficient way of updating data and is mostly used when your data goes through frequent changes. That is, if you're working on a data that has to be leveraged or changed on a daily basis, you can consider reference model. That is, which is basically one of the biggest advantages of using normalized data, where you have to model large data sets that follow a certain hierarchy, and you have to represent multiple many-to-many relationships. So that is where we use embedded model and reference model.
So what is MongoDB operators? Operators are basically special symbols or keywords that tell a compiler what mathematical or logical operations to perform. The operator improves MongoDB functionality by enabling the developers and programmers to construct sophisticated queries to communicate with datasets that are appropriate for their application and perform certain complex tasks to retrieve the data. Now, in general, we use the find command or method to fetch the data from collections using the query operator. Also, we need to use the prefix which is the $sign before the query operator. So let us just quickly understand the syntax of the operators in MongoDB. The syntax is followed as db.nameofcollection.find, and within the parenthesis we have to mention the field name and mention the semicolon, and then we have to mention the $symbol with the help of the operator that we want to use, mention the value, and finally we use the pretty method. So let us just quickly go through all these terminologies so that we'll have a better idea. Now, The name of the collection is basically according to the query operator we used in our query. This parameter is defined as the collection name from which documents have been retrieved. Next, we have the find method. Now, data can be retrieved from collections using this technique. We can also retrieve particular documents from MongoDB by using the find method with the query operator. Next, we have the field name. According to the query parameter we used in a query, this parameter is defined as the name of the field from which we are retrieving data. That is what we are trying to retrieve data from our collection is basically the field name. Next, we have the query operator name, which must be used to retrieve the documents from the collection in accordance with the query operations. Next, we have to mention the value. The value is nothing more than the field value that we used with the query operator to conduct logical or any mathematical operations and so on. And finally, we have an optional tag which is pretty. Now, since MongoDB output is generally in an unstructured format, so we can display our output using this technique in a structured format. And this is also optional, guys. So if there is a requirement to show the data in a proper structured way, you can use the pretty statement. So that was all about MongoDB operators, guys. So let us just move ahead. So let us now understand the different types of operators in MongoDB. Now, just like any operators in other programming languages, MongoDB operators are used to perform specific relational, mathematical or logical operations and produce the final result. Operators in MongoDB are broadly classified into three types. The first one is query and projection operator. Next, we have update operator, and then finally we have aggregation pipeline operator. Now, in MongoDB, the default for queries is to return all the fields in the matching documents. So basically, a query and a projection operator is used to perform certain calculation, wherein a projection query is used to specify or restrict the data result returned in query result. Now, by specifying a projection query, you can specify the fields you want to return or exclude. Now, similarly, we have other query operators, which we'll be discussing in a while, which are used to perform certain complex calculation on the data that you're retrieving from the documents. Next, we have the update operator, which basically updates the value of all the fields of the documents, which is matching the specified condition. And finally, we have the aggregation pipeline. So it basically provides the competent results as a result of processing the data, records, and document. So it is similar to that of aggregate functions in SQL, wherein it aggregates all the values within a document and performs certain aggregation operation like sum, maximum, minimum, and so on. So these were some of the main different types of operators in MongoDB. So let us now just get into detail and how they are further classified into various types. Now, query and projection operator further classified into various other types such as comparison operator, logical operator, array operator, element operator, bitwise operator, evaluation operator, and finally we have geospatial operator. Now, it is time taking to get into all of this stuff and explain each and every operator, guys. So let us just focus on the main operators that are frequently used in MongoDB. So firstly, let us discuss about the comparison operator, guys. Now, the comparison operators are basically used to compare two expressions and retrieve data from the documents. That is, the documents that we have stored. That is all the data from the collections, which are basically the group of collections, is basically a document in MongoDB that is stored in the MongoDB database. Now, we have several such comparison operators in MongoDB. Now, as explained earlier, we have to use the $sign with the help of operator that we have been mentioning. So basically, the operators take the $sign, and then we have to mention the operator that we have taken. So let us just discuss some of the operators here. The first one is EQ, which is basically the equal operator, which matches values that are equal to the value specified in the query. Next, we have $NA, which has a full form of not equal to, which is opposite of equal, and matches all the values that are not equal to the value specified in the query. Next, we have GT and GT, which is basically greater than and greater than equals to. This operator basically matches the value that are greater than the value specified in the query, or that are even greater than or equal to the value specified in the query. Next, we have the LT or LTE, that is less than or less than equals to. Again, as the word goes, it is similar. Again, it matches the values that are less than the values specified in the query, or it matches with the less than or equal values specified in the query in the document. And finally, we have the in and NIN, which basically matches any of the value that is existing or not existing in an array specified in the query. I know it is a bit of confusing, so let us just understand this with an example here. So consider this example on your right hand side, where you can see this image, which is basically a format of a document that is stored in a MongoDB database, guys. So let us say I have a collection named orders of, let's say, a stationery item database. Now I have further three different documents that are present in this collection. So basically a group of documents is basically a collection in a MongoDB database. So I hope you've understood what is a collection document and what is a database. So if you want to know more about it, we have a dedicated video on what is MongoDB, where we've explained clearly on all these terms and how it exactly works. Make sure you check that out, which will be quite helpful, and I would highly recommend. So as you can see, we have basically three documents here. We have an ID of three different people who have purchased certain products from a stationery and have different IDs. So we have three customers here: Rahul, Pranav, and Kirti. Now, if I want to perform comparison operation for this, let us just understand how equal and not equal operation performs. So basically, I'm taking an example here which says db.orders.find, where payment mode is equals to card. So basically, the compiler finds all the documents that is present in this collection where the payment mode is made through card, which instead of cash. So basically we have here the details of two customers who have used their payment mode as card, which is customer Rahul and customer Kirti. So in this way, it will return these two following documents. And similarly, we have any, which is not equal to, and I'm taking another example, which is db.ordersFind, order total is not equals to 600. Now, as you can see in the image, we have the third document of customer Kirti, whose order total is 600, right? So it basically evaluates this and returns the result, which has an order total which is not equals to 600. That is basically the first two documents. That is, it will retrieve the data from this document of the first, two documents, which is of customer Rahul and customer Pranav, whose order total is basically 2,450 and 5,800 respectively. So that is basically what is a comparison operator using EQ and NE, which is equal to and not equals to. Alright, moving ahead, let us now discuss what is GT and GT, which basically derives as greater than and greater than equals to. Again, let us consider the same, collection, same example that we have taken earlier. Now, the first query is basically for GT, that is db.orderFind order total is greater than 3000. Alright, so we are basically performing a search query wherein we want only those documents whose order total is greater than 3000. Now, if you look at the image, we have only, one document, which is of customer Pranav, whose order total is 5,800, which is more than 3000. And similarly, we have for greater than equals to, which is db.ordersFind order total GTE 2,450. So basically, we should retrieve the document whose order total is more than 250. Again, we have two documents here, right? Now we have a document of customer Rahul and the customer Pranav, whose order total is 2,450, which is equals to 2,450 that we have mentioned in our query. So basically, the details of the documents of customer Rahul and customer Pranav, whose order total is greater than or equals to 2,500. Alright, moving ahead, let us now understand what is LT and LT, which is negation or complete opposite of greater than and greater than equals to. Now, in less than, we have taken an example, which is again order total, which is less than 2000. So I guess we have only one record again here of customer Kirti, whose order total is 600. And similarly, less than or equals to 500. Now, I guess we have only one document again of Kirti, which is order total is 600. Oh, I'm sorry, less than or equals to 500, right? So we don't have any document of the customers which is less than or equals to 500, guys. Sorry, just Pardon me for my mistake, I didn't check. So we don't have any customers whose order total is less than or equals to 500. So it will basically retrieve a null value. So that were some examples of comparison operator. Let us move ahead with logical operators now. So basically logical operators return data based on the expression that evaluate the following condition to either be true or false. Now in general we have 4 different types of logical operators in MongoDB, which is and, or, not, and not, which is again similar with any other programming languages where we use a logical operator, and similar to that of SQL as well. Now basically the AND operator returns all the documents that match the condition of both the expressions specified. And OR operator returns all documents that match the condition of either expression specified. Next we have the NOR operator, which returns all documents that do not match the condition of either expression. This is basically an opposite of OR operator. And finally we have the NOT operator, which basically returns documents that does not match with the query expression in a document. So again, let us just understand with an example by considering the same example, which is the order collection. Now for first example, I'm taking AND operator, which says db.orders find and address city is either Delhi or payment mode is cash. Now if I look into the collection here, I have only one such document where address city is Delhi and payment mode is cash, that is the details of customer Pranav. So it will retrieve only the document of Pranav here. Next, if I consider the OR operator, which is db.orders find or city Jaipur or order total is less than or equals to 100. So we have Jaipur city whose I think it's of customer Jaipur, yeah, it's of customer Rahul. So it will retrieve that one, and it will also retrieve those documents whose order total is less than or equals to 1000. Now we have only one document of Kirti whose order total is 600, which is again less than or equals to 100. So basically the first document and the third document will be retrieved in our query in a final resultant set. And finally we have the NOR operator, which says the city is not either Delhi or payment mode is cash. Now other than city Delhi and the payment mode cash, that is we have Pranav whose payment mode is cash and he also belongs to Siri. So basically it will remove the document of this person customer Pranav, and it will fetch the first and third documents, that is the customer Rahul's and the customer Kirti. So those were some of the logical operator examples we have used. I hope you've understood. So moving ahead, let us now discuss some element operators, guys. The element query operators are basically used to locate document, based on the fields of the document. Now, what that I mean is, so basically every document has a field, right? Now, for example, let's say in the previous example, I've taken ID, customer name, order total, and so and so, which is basically a field. And now these fields have further values or elements to its name. Right, so the element operator basically finds all the documents based on the fields of the document that you're trying to search for. Now we have basically two element operator, which is exist and types. Exist operator basically returns documents that have a specific field. Now if I let us take an example. Let's say I have an collection employees, and I want to find the employee age as a field. I want to find if there is a field called employee age and his age is greater than or equals to 35. So I've taken this example which is db.employees find employee age exists true GT 35. So if there is any field in our collection of employee age and is greater than 25 or greater than 35, it will retrieve those documents. And similarly, we have the type operator, which returns document if field is of only a specified type. Now, if I take an example here, let's say if I'm trying to find a field employee age again, and it is of double integer type. So if I want a particular field data type, I can use the type operator here. So that was all about element operator, guys. And let us move ahead and finally discuss one of the main used operator, that is array operators. Array operators in MongoDB are basically used to query documents that include a field of arrays. Now we basically again have three different types of operators used in MongoDB. The first one is all operator. It returns documents from a collection if it matches all the values in the specified array. Next, we have the size operator. It returns documents from the collection to match an array with a provided number of elements in it. Next and finally, we have elim match, which returns those documents that match specified condition within each array element. Now, I know it is a bit of confusing, so let us just move ahead and understand with an example here. Consider the same example again, where we have three documents here. Now, for first example, I've taken the all operator, which is an array operator. So what I'm trying to find is, I'm trying to find a element or value which has, a notebook and a paper. So the query is followed as db.order.find orders item all notebook and paper. So if you look into the image, I think we have only two documents where we have this fields having notebook and paper. That is the first customer and second customer. If you look into the item name, we have notebook and paper in the first document, and second document also we have item name, notebook and paper. So it will retrieve these two documents. And next we have the size. So the size basically retrieves the number of array elements that you want in your resultant set. Now the query is followed as db.order.find, where order items is of size 4. Now if you look into all the three documents that are present here, we have only one such document where it has 4 elements. Now if you look at the first document of customer Rahul, order items, we have 4 different fields. That is, he has placed an order on notebook, paper, general and postcard. Now in contrast, if you look at to the other two documents where we have only notebook, paper and postcard for Pranav, and we have only notebook and postcard for Kirti. So which is against, or which does not satisfy the size operator. So it basically retrieves only the first one, which has 4 elements or fields. So I think that was all about the array operators, guys. I hope you understood about all the query and projection operators and its different types. Now again, we have several mini operators like geospatial, comment operator and so many, but which are not that significant in its usage. But anyways, if you want us to cover in our further tutorials, let us know, wherein we'll try to cover a more detailed version of it with a hands-on experience with the MongoDB database as well. And finally, let us discuss what is update operator, guys. And basically, MongoDB offers a variety of field update operators to update the values of the fields in documents matching the specified condition. So it is basically similar to that of DML command, which is an update command, which is used to update the values in the columns. Now, similarly in MongoDB, there might be a possibility that you have to update some values, and that is where we have the update field operators. Now, there are again various such update operators. So let us just go in through one by one. We have first one as current date, which is used to set the value of a field to current date, either a date or a timestamp. Next, we have INC, which is basically increment. It is used to increment the value of the field by the specified amount. Next, we have the min and max, which is used to update the field if the specified value is less than the existing field value or it is greater than the existing field value. Next, we have the MUL, which is a full form of multiply. It is used to multiply the value of the field by the specified amount. And finally, we have the rename. As a name suggests, this operator is used to rename a field within a document. So that was all about the operators in MongoDB, guys. I think we have covered almost all the important update operators that are used frequently on a general basis. I think this is quite enough for you to perform all the complex operations that you undertake to retrieve certain documents or values in your database.
Now we have moved to something called very important, that is installing MongoDB on Linux. This demo will show the steps to install MongoDB on Linux 64-bit. So what we're going to do, this command will download the MongoDB from the internet. So this command is going to untar the downloaded MongoDB which we have done. As we can see the bin. We're creating a directory called MongoDB. I'm just giving the path of the MongoDB to the bash RC file so that I can execute MongoDB bin from wherever I want. It's like environment variable setting the way we do for Java, for .NET. In Windows, we have environment variables. Similarly, in Linux, we have the bash RC file. So that is how the installation will happen of MongoDB on Linux system. And now we will see how the MongoDB gets installed on the Windows. So this is something which, again, I would really want all of you to really focus on. It's again simple, the same way as we did in Linux. So what we do is, so we have MongoDB installation going on. So what I do, okay. So I'm again talking about Windows and would recommend if all of you also follow the same. So first step is download Mongo. You will get some .zip version. Second step, rename it as MongoDB. So again, I'm telling you the scenarios so that everyone can go along. And place it under C. Place it under C. You can place it anywhere. Again, for better, let us keep it under C. So now I'm assuming all of you have your MongoDB under. I'm assuming your MongoDB will be over here. This will be a folder. Inside this, you should be able to see bin now. And the bin should have all of the different commands. Now what I would recommend is, instead of just double click in MongoDB, open a command prompt. Open a command prompt. Go to C MongoDB bin. Go to this path, up till the bin. And now when you are in the bin, type MongoDB and put an enter. It means you're saying that start the Mongo database instance. You should see on the screen, waiting for connections to open on the port 27017. This is what you should see on the command prompt. Fifth step, open another command prompt. Go to C MongoDB and type Mongo and put an enter. Now, what you should see in the your current command prompt should say connected to test, and your previous command prompt, that is on the step 4, should now say one connection open. Okay, so this is what your scenario should be. So please, all of you, follow these steps.
What are regular expressions in MongoDB? Regular expressions are used to match specific patterns in a document. It is basically nothing but finding strings within a document. Now, it's possible that you won't always know the precise field value to search for when retrieving documents from a collection. So, in order to help with data retrieval based on search values that match a specific pattern instead of the whole word or a string, regular expressions can be used. It comes with multiple options also, so we can customize our query to check if a field contains a string or not. Now, why we use regular expressions? Now, there are many reasons, but these are some of the important factors on why we use regular expressions, just like in any other languages we use, right? So even we discussed regular expressions in SQL also in our previous tutorial. So if you haven't checked that out, make sure you check that out on our channel on SQL playlist. Now, the first reason is obvious, that it provides patterns or a sequence of characters for matching text and define search patterns. Now, like I said, instead of searching the whole value in a particular field, you can just write a simple pattern that you are aiming to search for. Now, it retrieves any unidentified field in a document easily as well. And finally, it queries databases to find a smaller subset of data within a collection. So instead of retrieving all the fields again in a document, you can retrieve only a portion or a part of data from that collection using regular expressions. Now, this can be achieved with the help of the regex operator. Now, what is regex operator? The regex operator provides regular expression capabilities for pattern matching strings in the queries. So in simpler terms, using this operator, one can search for the given string in a specific collection. So if the exact field value is unknown, that a user is looking for in the document, this operator can turn in handy. Let us now understand the syntax of the regex operator. Now we have various different types of syntax. The first one is a generic syntax where we are using a delimiter, which is the syntax is followed as db.collectionName.find, and within the parenthesis mention the field name that you're using, that you want to find a subset of data or the a specific pattern that you're searching for, and then mention the regex keyword and then the pattern. Now if you look at the pattern, inside the pattern I've mentioned the delimiter, so which basically means that you can like find any pattern of a string value. Let's say if I want to find a person's name who has, let's say, RA in their name, so I can just simply put a delimiter, and inside that I can put the two strings, which is RA. So for example, it can match Rahul and any such other names in the same way as well. So in that way, you can use the regex operator without using any actually the regex pattern. Next, we have another syntax of the same regex operator, which is mention the field and mention the regex operator using the $sign. And let's say if you want to find a specific character, so we use circumflex or to the power, which is a meta character, to match a string at the beginning, and we use a $sign at the end to match a particular string that ends with a particular value. And next, we also have another type of syntax for regex operator, which is field, mention the field name and the regex keyword, and mention the pattern. It can be anything. It can be a generic one where you can use delimiters, or you can even use the circumflex or the $sign. And apart from that, we can mention the options as well. Now we have various different options like S, I, X, and M. Now what the S option does is it allows the dot character to match all the characters, including the new line characters that you are entering in a document. Now we use X as an option to ignore all white space characters in the regex pattern. Next we have I, which is used to match both upper as well as lowercase patterns in the string. And finally we use M in order to specifically search for the circumflex and the $sign inside the string. So if these are not used, these anchors match at the string's end or beginning. Now this is a bit confusion for you guys, so let us understand. You'll understand it in a more better way when we get into the execution part. So I hope you understood what is regex operator. So let's just understand how regex operator works with a simple example here. Now let's say I have a collection. Let's say its name is orders, and within the orders collection, I have 3 different documents here of 3 different customers like Rahul, Pranav, and Kirti. Now let's say if I want to find the customer name who has RA in their name. Now it can be at the starting, it can be in middle, or it can be elsewhere, or in the end, I mean. So for that, I'm just using a delimiter and I'm mentioning 2 string values, that is R and A. So it will only match Rahul because we have RA, and similarly we have Pranav, who is also having R and A strings characters in their name. We also have Kirti, but she doesn't have RA, so it doesn't match. So we only will get the output of only these 2 documents. Now similarly, let's say if I take another example, wherein I am writing another query which is db.orders.find, and I'm mentioning the field name payment mode, and I'm finding for a particular string here which starts with CA, which is the payment mode in the document should start with CA. Now we have payment mode as card, cash, and again we also have card and cash are basically the 2 types of payment mode. So it will basically retrieve all the 3 documents. So let us now understand another example here. Now let's say I've written a query which is db.orders.find payment mode. I think there is a mistake here. So let's say if the orders item, I'm taking the field as order item, and I'm mentioning the regex keyword again. And here I'm mentioning $OK. That means the item name in the orders item, the item name should end with OK. So we have different item names here like notebook, paper, general, and postcard. Now only one item name, which is notebook, which has OK in the ending, right? So the $symbol basically matches the string in the end. So since it has OK, the 2 specific strings in the end of the document, so it will only match the notebook. So since we have notebook in all the 3 documents, again we can retrieve the 3 documents in our final output. So this is how regex
operator basically works. So let us now directly jump into MongoDB shell for execution part and see how it gets executed with some more different examples. So as you can see, the database MongoDB shell has started. So let us just use the show DBS in order to display the database that are present. So we have the simply code 1, which we'll be using again. So I'm just using simply code 1. And let us now see the collections inside this. We have the employee collection. So let us just use that. So in order to find the data that is present, we will use the db.collection name, which is employee.find command. So it will display all the documents that are present. So firstly, let us discuss a simple example where we'll simply use the delimiter operator in order to find the first name of the employees in our documents whose name can have li. Okay, so then we're just providing a pattern here which is li. So the query would be db.employee.find, open the brackets, square brackets, and within the flower brackets mention the field name, that is first name, and then mention the delimiter, which is this. And our pattern that we are trying to find is li, right? So mention li, and again close the brackets and enter. So all right, so we can see some of the documents have been retrieved. Let's say if you take the first document here, we have the first name Valli and his full name is Patabala. So you can see we have characters li at the end here. So similarly, if you take the next document, we have Shelly. Again, we have li at the end. And if you take this example, we have Julia, whose name has li characters in the between. And next, we also have Williams, who has li in between again. So these are the 5 documents that are received. So irrespective of the position in which they are, it basically retrieves all the documents that has li as a substring in the document. So in this way, you can use the regex operator also simply without using the regex keyword. So let us now understand another example, guys. So let us say I'm trying to find a specific pattern where I want to find the first name of the employee whose name starts with sh. So in that case, what I'll do, I'll write a simple query as db.employee.find, open the brackets, mention the field name, which is first name, and again now we'll write the regex keyword here. Since we are particularly finding a pattern which says that the name of the employee, the first name of the employee should start with only S and H. So mention the $symbol, mention the regex keyword and semicolon, and then within the double quotes, mention the words or the pattern that you're trying to searching for. So I'm keeping it as S and H. So let us close the inverted commas. Let us close the flower brackets and finally the square brackets. I think we need to mention 2 flower brackets. So I think we're good to go. So let's just execute the statement. All right. So as you can see in the resultant set, we have some documents being retrieved. So firstly, if you look at the document of this one, who's the employee whose first name is Shelly. So it's starting with SH. Next, we also have employee ID 123 whose first name is Shanta, again starting with SH. And similarly, we have employee ID 205 whose first name Shelly starting with SH again. So you can use the regex operator in this way to only find a particular pattern. Now let us take another scenario here. So if you look at this previous example, now we are mentioning the pattern as capital S and H. So it is case sensitive, right? So it is only displaying the records of those employees whose first name is starting with capital S and the second letter, which is small h. So let's say in a different scenario, we want all the employees' name whose name is having let's say capital S as well as capital H. So in that case, you need to use the options command. So let's say again, if I am trying to find the first name of an employee whose first name starts with JU. So it can be capital J or small u.
So in that case, you'll need to use the options, and the option that we are going to take is, which is basically I. So I'm just going to execute this statement. So just follow it with me. db dot employee dot find, and within the square brackets, open the square brackets and the flower brackets, first name, and open the flower brackets again, mention the $sign, mention the regex keyword, again semicolon. Now the pattern that I'm searching is JU. It can be anything. So we are just going for case insensitive here. Now for that, we have to basically use the options command here. So mention the $sign, options is the keyword, and mention the colon, and within the inverted quotes, mention I. So what basically this I does is, it will retrieve all the records irrespective of whether they are in uppercase or lowercase. So let us just close the flower brackets again and let us execute it. So as you can see, we have only one record or one document that is being retrieved, which is of Julia Nair. Now, if you look at the command that we have taken is small j and small u, but in the resultant output, the document is that which has been retrieved is capital J and small u. So in this way, you can use the options command in order to find all the documents irrespective of whether they are in smaller case or uppercase. So that was another scenario, guys. So finally, let us look into another scenario where you want to find a specific document starting with a particular substring or a pattern or a value and ending with a particular value. So firstly, let us take an example of this document wherein we'll search for the job ID which starts with AC. So in that case, the following query would be db.employee.find, mention the flower brackets. So we are taking as job ID, which is our field name. Mention the regex keyword again. So the pattern that we are searching for is, so circumflex, you have to mention this symbol which is a meta character, and the job ID should start with A and C. So it is must. So this condition basically checks for all the job IDs, the name of job IDs starting with AC. So let us just close this and enter. Alright, so in our resultant output, we have two different documents present. So if you look at the first document, we have job ID as AC MGR, and next to the second job ID, we have AC accountant. So this was another scenario where we are using, where we are finding documents only with the help of the regex operator and a search pattern, wherein we are only finding the job ID of those employees whose job ID name starts with AC.
Aggregation, process data sets and return calculated results. It is run on the MongoDB instance to simplify application codes and limit resource requirements. Following are the characteristics of aggregation. Uses collections of documents as an input and return results in the form of one or more documents. Is based on data processing pipelines. Documents pass through multi-stage pipelines and gets transformed into an aggregated results. The most basic pipeline stage in the aggregation framework provides filters that function like queries. The pipeline operations group and sort documents by defined field or fields. The pipeline uses native operations within MongoDB to allow efficient data aggregation and is the favored method for data aggregation. So MongoDB also would provide out-of-box support for MapReduce as well, but again that is not a favorable or recommended approach by MongoDB to use the aggregation. So they have the aggregation framework which will does most of the tasks. Now this example, please understand what is happening over here. There is an orders collection and I'm running an aggregate pipeline on top of that. The orders collection, how does it look like? see on the left hand side, we have a customer ID, we have amount, we have a status. You can see there are two customer IDs A123. So there are three customer IDs A123, and there is one customer ID B212. So what happens is, first of all, the data goes through the match pipeline. The match pipeline. And what is our dollar match? The dollar match is give the status as A. That get me only those records who has the status as A. So we come to know from looking at the orders collection that only the first three documents will come. Only the first three documents will come in the dollar match. And that's what's happened. So we have two documents from A123 and one document for B121. After going through the data from the match pipeline, what happens? The data goes to the group pipeline. What happens in the group pipeline? I'm grouping by customer ID and I'm making an alias called total. It means total is the key. And what will the total have? Total will have a sum of amount. And what is the amount? The amount we have a key in the documents in the orders collection. So see what is happening is the customer ID is grouped and the amount gets plussed. The total we have 750 and again the total we have 200. There was no aggregation supposed to be done. So again, this is very important from MongoDB's aggregation point of view. The pipeline operators and indexes. So the aggregate command in MongoDB functions on a single collection and logically passes the collection through the aggregation pipeline. We can use the dollar match, dollar limit, dollar skip stages to optimize the aggregate operations. You may require only a subset of data from a collection to perform an aggregation operation. Therefore, use the dollar match, dollar limit, and dollar skip stages to filter the documents. Once they are filtered, I can actually group them up. The dollar match operation scans and selects only the matching documents in a collection when placed at the beginning of a pipeline. Placing a dollar match pipeline stage followed by a dollar sort stage at the beginning of the pipeline is equivalent to a single query with a sort and can use an index then. Place dollar match operators at the beginning of the pipeline if possible, because that will make all the sense. Dollar match is the way query. Again, I want all the countries which are India, and again, once I've got that, I can put a group operation on top of them to group things up. There are different stages, through which it passes. Again, as I talked about, first one is the dollar project. What happens in the dollar project is like a view. Adds new fields or removes existing fields and does restructure each document in the stream. It returns one output document for each input document provided. What the dollar match will do? Dollar match is like where filters the document stream and allows only matching documents to pass into the next stage. For each input document, it returns one output document if there is a match or 0 if no match is found. Dollar group is like the group by. Groups document based on a specified identifier expression and applies logic known as accumulator expression to compute the output document. Dollar sort again rearranges the order of the document stream using specified sort keys. Provides one output document for each input document. So again, we have some more as well. Again, as I told you, dollar skip will skip the number of documents and passes the remaining documents without any modifications to the pipeline. Returns either 0 documents for the first n documents or 1 document. Dollar limit. What will the dollar limit do? Dollar limit will pass the first n number of documents without any modifications to the pipeline. Returns either 1 document for the first n documents or 0 documents after the first n documents. So again, the dollar sort, the dollar skip, the dollar limit works exactly the same way how they work in the find. And then we have dollar unwind. If we have an array and we really want to unwind every element in an array, we use a dollar unwind. So that is what deconstructs an array field in the input documents to return a document for each element. If I have something called hobbies, TT badminton, so that won't be an array. It'll be 3 different elements, 3 different keys, that is badminton, TT, and volleyball. So again, the aggregation example which you see over here. So the aggregation operation given below returns all the states with total population greater than 10 million. So that again is the same slide which, the same link which I have sent you. This example is from the same documentation page. So please see on the slide what is being shown. So what I'm doing, so zip codes is a collection. I'm putting an aggregate pipeline on top of that. I'm grouping in on the state And what I'm saying, you group it on the state and calculate the total population and give the sum of the total population. So again, if I remain on the first query for some more time, again, be with me. I'm going slow, very slow. db.zipcodes.aggregate. Zip codes is the collection. I put an aggregation framework on top of that. The array starts. In the round brackets, there is an array. Inside the array, there will come different pipelines. The first pipeline which came is $group. In the $group, I specify the ID with which I'm gonna group by a state. And again, I give the aggregating function, which is total population is the key or a alias. And I'm telling total population will be derived by calculating a sum of all the population. To reference the population, I'm using $pop. And again, I'm doing a $match. That get me only those states which are having a total population of greater than some 10 million. So very clear, this thing should become that how this query is running. So in this operation, the $group stage does the following: group the documents of the zip code collection by the state field, calculates the total population field for each state, returns an output document for each unique state. So the aggregation operation given below returns usernames sorted by the month of their joining. So again, what we have over here is, so db.users.aggregate $project month joined. Again, it is $month : $joined, and again we have the name as $_ID, and _ID is 0, and again we can just sort it with the month _joined. So again, both the examples would have cleared you how the group by actually happens in MongoDB.
Also, if you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who likes to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM. The link in the description box and the comment section should navigate you to the homepage where you can find the complete overview of the program being offered.
Now, MongoDB projection helps to return the specific fields from the query, or you can say from the MongoDB collection. Now, by default, when we query any collection in MongoDB, it returns all the fields in documents. Now, as you know, MongoDB is a schemaless database, which is a NoSQL database and has a different structure to that of relational database. Now, the tables in relational database are called as collection, and rows are called columns. We may not want all the records from the collection, but a few of them in the resultant set. So in that case, we use MongoDB projection. Using projection document, which is used to limit the amount or fields in the data present in that document. So in a nutshell, if I would say, projection means selecting only the necessary data rather than selecting the whole of the data present in the document. Now, similarly acts to that of where conditional clause that we use in SQL. Suppose if I have a document which has 10 fields, and you need to show why we use a popular NoSQL and open source document oriented database, which allows for highly scalable and flexible document structure, which is faster than relational database because of its efficient storage and indexing techniques. And being a NoSQL database, it is designed to handle large amounts of data. So DB will process a lot of unnecessary data, and when you want to retrieve specific information from a large number of records. So to overcome this problem, we use projection query. Now, some of the reasons. Now, when using projection to remove unused or unused fields, the MongoDB server will have to fetch each document into its memory and then filter the results to return. Actually reduce the memory usage, but can save the significant network band for query results depending on the data model and the fields projected in your documents. And it only returns indexed query results without fetching the full documents. Which is basically the main use case of projection, which basically eliminates all the fields that are unnecessary for the user and particular fields within the document. Then he can use the projection query operator. And finally, filter data without impacting the overall database performance. Now, by default, is return all fields and matching documents. So, if you need all the fields returning full documents is going to be more efficient, having a server manipulate the result projection, however, to improve performance. And that is one of the main consideration when we are using MongoDB projection. So these are some of the reasons on why we use MongoDB projection. Alright, let us now understand how MongoDB projection works. Now, in general, to retrieve the data from the documents, we use the find method, which retrieves data from all the fields within a document without any filtering. So let us now understand the syntax of MongoDB projection operator. Now the syntax is followed as db.collectionName.find, and within the parenthesis mention the field names, that is, I'm taking your field 1 and its corresponding value, field 2 and value 2. Now the values that I'm talking about is, if field value is set as 1, which is a Boolean expression which is equals to as, it will basically show the data in that field. Field value is, if the Boolean expression, it hides the data in the field. So let us understand this with an example, guys. Only then you will get a clear understanding of it. Now I have, let's say, a collection of certain documents. Let's say the collection name is orders, and I have 3 such documents here which has various fields like ID, customer, address, payment mode, email, order total and order items. Now if I want to display all these documents, what I'll do, I'll basically write a query using the find method, which is followed as db.orders.find. So it will basically retrieve all the documents without restricting any of the fields that are present in our collection. Now let's say if I want only particular field that I want to display in my resultant set. Now let's say if I have the payment mode and the order total field, and I want only them to display in the resultant set without displaying all the fields that are present in each of the document. So in that case, I'll write a query as db.orders.find, and inside the parenthesis, I'll mention payment mode : 1 and order total is 1. Now, since I've set the field value to 1, it will only retrieve those values. And similarly for order total also, it will retrieve only that particular field value. So this will basically be the output of our resultant set. That is, it will show the ID object, the payment mode of the 3 documents, and similarly the order total of the 3 documents. Now, by default, we have the underscore ID, which is a default value which we cannot change it. So if at all, if you want to override and change it, you can mention it to 0. Now let's say I'm taking the same example here. Now instead of just writing payment mode to 1 and order total to 1, I'm adding another constraint, or I'm projecting another field which is of ID, and I'm setting it to 0. Now if you see in a resultant set, we do not have the ID field. So in this way, you can use projection in order to restrict certain fields from your resultant table set without actually retrieving all the data that is present in your documents. So let us now jump into Mongo shell and execute this example and see how it is working. So as you can see, Mongo shell has been started. Now, I don't want to get into the details of all of it. We will cover in a separate tutorial where we'll understand how to create a database and how to create a collection in MongoDB separately, guys. Stay tuned to the channel for that. So we'll just cover how we'll implement MongoDB projection with certain examples here. Now, basically, in order to retrieve the databases that are present in our MongoDB, we have to use the command as show DBS. So it will list out all the databases that are present. We have admin, config, local, and simplicode 1. Now, I have already created the simplicode 1 in hindsight before itself, so that we can save a bit of time. And I've also created a collection in that. So before you see the collection and the documents that are present in it, you have to use the simplicode database. So for that, we'll use the simplicode 1 as our command. So as you can see, it is saying that switch to DB simplicode. Now, if you want to find all the collections that are present in database, you have to basically write as show collections. So it will list out all the collections in that. Now, as you can see, I have a collection that is of employee here. So for example, we'll consider this same collection. Now I have this below collection named as employee with let's say certain number of documents in that. Now if I query the collection in MongoDB shell, if I write a command to it to return all the documents or fields from the matching documents by default, it will return all the documents. So for that, we'll use a statement like which is of db dot mention the collection name, that is employee dot find. So find method is used to list out all the documents. So you can just see that we have a lot of documents in our resultant set. Let me just scroll and go to the top. So as you can see, we have different documents, a number of documents, and it has different fields like ID, employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, department ID, and so on. So you can see we have a lot of documents. So let's just count how many documents we have. For that, you can use the count statement. So db.employee.count. So you can see we have a total of 50 documents present in our employee collection. Now, if you look at our resultant set, after we used the find method, you can see it has returned all the fields of the document from the collection. Now, but what if I want to fetch only a particular field, like let's say first name, last name, email, or even their salary? How will we do that? Now, the answer is using MongoDB projection. We will project specific fields to return from the query. Now, so before proceeding to MongoDB projection, guys, let's recall how we fetch certain fields from, a traditional SQL database so that we can have a clear understanding. Now, let's say suppose the collection employee is a table in SQL, and let's say all the fields like employee ID, first name, last name, so on are its columns. Now, I want to fetch the only let's say first name, last name from the table. So in that case, what we'll write, we'll basically write a query as select first name, comma, last name from a table that is employee, right? I hope I'm clear with this. So it is similar to that in MongoDB, wherein we are executing this query as using projection. So let us now see how we do projection here. So let's just consider an example here. Now let's say I'm writing a command as db.employee.find. And let's say if I want to fetch all the documents of all the employees whose department ID is 30. So in that case, what I'll do is department. So it is case sensitive, guys. So make sure you write in the capitals or whatever the field is written as. So mention the column and within the double quotes mention 30. So close the parenthesis and close the square brackets as well. So it will basically list out, as you can see, all the documents of the employees whose department ID is 30. So we can see we have employee ID of the employee 114, 115, 116, 117, 118 and 119 whose all their department is 30. Now again, even if I'm returning a particular field or a condition, it is also retrieving all the fields from all the documents. Now I don't want that. Now I want only a particular field. So what in that case, we will project certain fields without returning all the fields from our documents. So let us see how it works. So the query is followed as db dot mention the collection name employee, find, open the square brackets, and let's say I want to retrieve only the first name. So I'm setting it as 1. As we discussed earlier, if you want to retrieve the particular field, you have to mention 1. And similarly, I want to retrieve the last name as well. Last name, column, and 1. And also let us take another field. Let's say salary, right? We have salary also. Let us just retrieve that as well, 1. All right, close the parenthesis and close the square brackets and enter. So we do not have any output here, guys. That is because we haven't mentioned the parenthesis before the find method. So let me just copy paste and we'll see how it is. So after the find, we'll have to mention the parenthesis again, and then I think we're good to go now. So as you can see in a resultant set, now since we have only mentioned the first name, last name and the salary, it is only displaying the results, only certain fields, that is the first name, last name and salary in a resultant set. Now by default, this ID object is retrieved with the command. So if you want to eliminate that as well, you can keep the ID to 0. So let us just execute that. So let me just copy this again, paste it, and mention another criteria, that is the field. Now the field should be, the field that is of ID should be 0. So close the parenthesis. So let us just execute this and we'll see how it is the output. So as you can see, now only we have the first name, last name and salary of all the employees. So we have just basically eliminated the object ID as well. So if you want only the first name, last name and salary in your output, you can just mention the field names and mention 1 if you want to display in a resultant set. And if you want to if you do not want to display those certain fields, you can mention as 0. So in this way, you can use the projection query operator in order to project only certain fields from all the documents. So yes, I guess that was all about the MongoDB projection, guys. Now, projection query operator can be quite useful when you're handling a lot of unstructured data. Let's say if the database has like 10,000 or even 1,000,000 records. In such case, if you want to return a specific number of fields only, now a document can have any number of fields like 10, 20, 30, 40 and so on. So in some cases, if you want to retrieve or specify only certain number of fields in your resultant set, in that case projection operator can be quite useful. And I know it is quite confusing at the beginning, so you just need more practice to understand this in a more better way. So that brings us to the end of today's session, guys. I hope you've understood all the topics and concepts covered in today's session.
So firstly, what is sharding in MongoDB? Now, sharding is a method for distributing a single data across multiple databases, which can then be stored on multiple machines. This allows for large data sets to be split into smaller chunks and stored into multiple data nodes, increasing the total storage capacity of the system. So for example, let's say I have a database which has 2 million users that are running on my database frequently. So the single machine has a capacity to only hold 2 million records in that. Now, for instance, my business is growing, and with the ever increasing demand of data, the data is being piled up in more numbers. Now, for example, the 2 million has been raised into 3 million, and in that case, the operations on that database can be quite difficult because there is a huge traffic of data that can be applied on that database. In that case, I can basically split the database into 2 different instances where I can make 2 machines, or I can basically store the data in 2 different servers wherein I can have 2 different capacities. Now, let's say I've divided the 2 million to 1 million and 1 million. Now, I further can have a total capacity of total 4 million, that is 2 million and 2 million in each database. So this is what sharding is based upon. Sharding basically distributes the process and stores a single data set into multiple databases. Now, the purpose of any database distribution is to enhance the scalability of the applications, and sharding is an excellent way to keep the data safe across different resources in MongoDB. Database sharding is achievable by breaking down big data sets into simple subdivided data sets across multiple instances. Now, this single database cannot handle a database with large data sets, right? As it requires large storage, and bulk query operations can use most of the CPU cycles, which slows down the processing of the system. For such scenarios, we need more powerful system. So now one approach is to add more capacity to single server, such as adding more memory and processing units, or adding RAM on the single server.
then it is basically known as scaling. Now we can do scaling in two ways. First one is we have vertical scaling. Vertical scaling basically refers to adding more resources. For example, adding a new CPU or increasing the RAM, or instead adding a new disk size to your server based on your demand. And next we also have horizontal scaling. Horizontal scaling involves adding more and more processing units of physical machines to your server or databases. So it is basically used to divide a large data set across multiple systems and serve a data application to query data from multiple servers. This approach is basically called as horizontal scaling, and MongoDB handles horizontal scaling through sharding. Now let us now understand why we exactly need MongoDB sharding, guys. Now we learned that in our previous tutorial about replication, wherein we learned that replica sets gave us the ability to hold data in multiple databases, and thus given us a certain level of fault tolerance and data duration. And however, this approach has certain limitations. As previously mentioned, guys, all write operations in replication go to the primary nodes. As you can see here, we have the primary node here. It is going to the secondary node, and all the write operations are basically done on this primary node, and all the read operations are basically processed to the secondary node, which makes it the crucial thing of any system, right? This means that if the system grows, this primary node will be overused. So in that case, eventually it will be limited with hardware limitations like RAM, number of CPUs and disks, and etc. So in that case, it is quite difficult, that a database can be of efficient way to address the demand or process the data within the database. So that is where MongoDB sharding comes into picture. Now, since it is a limitation of replication, that is where, as I said, sharding comes into play. When database may struggle to handle more and more data and the query traffic increases, in that case, you need to distribute the data into simpler or secondary multiple machines. Now, another reason is MongoDB instance is unable to manage write operations. As I said earlier, the database in replication, you're basically copying or duplicating the data from one MongoDB database into another. In that case, it becomes difficult for one single database to manage all the write operations, right? So in that case, we need sharding. Next, memory cannot be outsized enough in case if your data set is large. For example, if the database is working on large data sets, in that case, memory cannot be over settled, or you can incorporate memory if the data set is too large. And finally, which also impacts the database maintenance also, and vertical scaling is nowadays too costly, and in that case MongoDB sharding comes into picture. So those were some of the reasons why we need MongoDB sharding. So let us now move ahead and let us understand how MongoDB sharding works. Now, before MongoDB sharding, the working of MongoDB sharding, we need to understand the MongoDB sharding architecture. Now, implementing the concept of sharding can be done with the use of clusters. So when I say about clusters, sharding clusters are basically the combination of multiple shards, Mongo's processes, and configuration servers. So if you look into this image, we basically have an app server wherein we have various routers, and we have a Mongo's instance of MongoDB, Mongo's process, and we also have configuration servers, so config servers, which are basically the replica sets, and we have different shards where we are basically trying to break down a single huge database into further shards or simpler pieces. Now this is done with the help of a sharding key. Now on sharding a MongoDB dataset, a shard key is automatically created by default. The shard key basically can be in form of an indexed field or indexed compound field that will be used to distribute the data among the shards. Generally, the shard key is used to distribute MongoDB collections documents across all the shards, where the key consists of a single field or multiple fields in every document. So that brings us to the main part, which is how MongoDB sharding works now. Now MongoDB sharding works by creating a cluster of all these MongoDB instances consisting of at least 3 servers, which we'll be discussing in a while. So the shared cluster or the MongoDB sharding cluster consists of three main components, which is basically shard, Mongos, and config servers. Now, when I talk about shard, a shard is basically a single MongoDB instance that holds a subset of the sharded data. Shards can be deployed as a replica set to increase availability and provide redundancy. Now, the combination of multiple shards creates a complete data set. For example, if you're trying to break down, let's say, a 5 TB data set, which can be broken down further into 4 shards, each combining of 100 GB of data from the original data set. So that is what a shard is all about. Now next we have Mongos. Mongos acts as a query router, providing a stable interface between the application and the sharded cluster. This MongoDB instance is responsible for routing the client's request to the correct shard. And finally, we have the config servers. Configuration servers basically store the data and the configuration settings for the whole cluster. So if you look at it, look at this diagram, we have a router which is having a MongoDB instance, and we have configuration servers wherein we have primary, secondary servers in that, and also we have shards where we are basically dividing again into primary and secondary. So the application communicates with the routers, which is basically the Mongos, about the query to be executed. Now the Mongos instance consults the config servers to check which shard contains the required data set to send the query to that shard. And finally, the result of this query will be returned to the application. So you need to understand that it's important to remember that the config servers also work as replica sets here. That is why we have primary and secondary nodes here as well. So this is how basically how MongoDB sharding works. Now the idea is to have basically multiple replica sets with multiple primaries that will divide data and load it among themselves. And each of these replica sets is basically called a shard. But multiple shards are not enough to achieve the proper functionality of this kind of system. So, and that brings us to the final component or final, thing to our session, which is basically the advantages of sharding. So, in database sharding, gives a lot of advantages. Now, one of them is increased storage capacity. So, when data gets distributed across the shards in the cluster, each shard contains a subset of the total data in the cluster. And on increasing the data volume, the additional shards grow, which leads to expanding the cluster storage capacity. Sharding also increases the read and write throughput in the database also, guys. Now in MongoDB, the read and write workloads are easily distributed across the shards in the sharded cluster. It allows each shard to process a subset of the cluster operation. So both the read and write performance can be directly scaled horizontally across the cluster by increasing the shard count, and which again ultimately results in high availability of data. Now with an unsharded database, an outage in one database shard has a caliber to impact the entire application and loosen its functionality or even completely stop it. However, with a sharded database, if there is complete unavailability of one or more shard replicas, only a few parts of the application or the website which is available to some users. However, the other shards continue their operation without any concern. And finally, sharding facilitates horizontal scaling. Now, one more reason developers love database sharding is that it facilitates horizontal scaling, which also means scaling out your databases. This means it allows you to have parallel backends and carry out tasks simultaneously with no hassle. Whether the focus is on writing or reading operations, scaling out can add a big advantage to enhance the performance and also eliminate complexities. So these were some of the main advantages of sharding, guys. So that brings us to the end of today's session. Now you might wonder how sharding and replication are different from each other. So whenever you're thinking about sharding or replication, you need to think in the context of the write and the update operations that you're performing on your database. So if you don't need to scale write processes, then replication, as it's fairly simple, is a good choice for you. On the other hand, let's say if your workload is mostly on write operation most of the times, then at some point you'll hit a write operation that is compulsory needed for you in any case, right? So if write request comes comes, then Mongo basically blocks other write requests, right? So these are all the write request blocks until the first request will be done. So if you want to scale this write operations and want to parallelize, then in such case you need to implement sharding. So if you want to know further about the replication process, we have a dedicated video on our channel, so you make sure to check them out. Check that on our channel. We'll leave the link in the description, wherein you get idea on how replication is different from sharding as well. What are relationships in MongoDB? Now, MongoDB relationships are the representation on how different documents present in a collection are connected logically to each other in database. MongoDB relationships helps in various different factors, right? For example, relationships enforce data integrity in relational databases, and it also establishes relationship between documents, which can help refine the database structure as per your requirement. Now, we know that MongoDB is a NoSQL database and has a lot of unstructured data. So in order to properly confine all the documents into a proper format and refining them into a proper structure is quite beneficial, not just in terms of saving the data, but it also affects the performance and makes execution time also shorter. And finally, it basically links important entities in the database. So that is what relationship in MongoDB is. Now, there are different types of MongoDB relationship here, guys. We have embedded and reference method. So data relationship can be achieved through these methods, wherein embedded documents relationship between data is by storing related data into a single document structure. Now, let's say if I have a collection and I have two different documents. Now, as the word suggests, which is embedded, I'm basically storing these two different documents into a single document structure, which is known as embedded document relationship. And similarly, we have a document referenced method or simply reference method, which is used to store the relationship between data by including any links or references from one document to another. Now, we'll understand this with an example here. Now, if you consider this embedded model, collection which I have here, let's say I have, a details of a person whose name is Pranav, whose ID is 118025. His contact details are there, his phone number, his email address. Now, this is basically one document, right? Now, similarly, I have another document wherein I'm having his grade details. That is his subject, which is CS203, and the score, that is the grade that they have achieved, is B. Now, instead of having two different documents in the collection, I'm basically merging them. That is, I'm embedding both of these into a single document. So this is what embedded model does. It basically combines two documents into a single document structure. And similarly, I have reference model. Now, reference model basically links two or more documents, right? Now, let's say I have again a student collection here, which is of Rohan, whose contact details, his email ID, phone number, and grade are being displayed here. So let's say I have a collection. And in that, I have three different documents, which is student, contact details, and grade. Now, instead of having three separate three separate documents, I can simply combine these, or I can link with the help of user ID. I can basically combine the contact details as well as the grade into a single document. So this is how reference model works. That is by referencing or linking two or more documents into a single document structure. So that was all about reference model, and that is main difference between embedded and reference. Now, we have these two embedded and document reference relationships, and these can be achieved by three different methods. That is, we can have one-to-one relationship, one-to-many relationships, and in document reference relationship can be achieved through many-to-many relationships. Now, let us now understand what exactly these are. All right. So, one-to-one relationship, basically, if you have any one field, it can only have one value. In such case, it will consider as one-to-one relationship between any data that is present in the document. And if you consider one-to-many, now as the name suggests, one-to-many. So when one field has multiple relationship between the data in between documents that is stored in the collection of a database, in such case, one-to-many relationship model can be used. And similarly, we have many-to-many. Now, let's say I have, three different, document structures wherein I have two or more entities within a document and having, let's say, an array of details present in a single collection or in a document. So it can have multiple relationships, right? So in that case, we need to use many to many. I hope this is clearly understood. We'll get into detail by each of them. We'll consider each of the relationship model and understand how it is different from each other with an example now. So firstly, we have the one-to-one relationship, guys. Now, one-to-one relationships are created by linking two documents from different collection using a shared key, that is sharing the object ID of one collection to the other, which is a property of the same value. Now, often the best way to create this relationship is to have the child collection query, which is the key value of the first collection. Now, object IDs, which basically are created by default in MongoDB, are commonly used to make this connection, although it can be of any other type. Now, let's say I have another example here, which says that I have a user's collection, which has ID by default, name, John, and age is 40. And I have address collection as well, which has ID, which is by default again, and the address details like street name as Church Street, number, I'm having 1421.0, city as New York. Now, what one-to-one relationship does is it links two different documents, right? So in order to combine these two, I need a common property or a common key. That is done by using the object ID here. So if you look at the result, the resultant set of the document has been combinedly showcasing the details of the user as well as his address. So you can clearly see that we have the object ID, the details first here. Next we have name John, age 40, address. Again, in address, we are basically documenting or adding the data of the address in the same document itself. So this is one-to-one relationship. Let us now move ahead and understand what is one-to-many relationship. So one-to-many relationship is another relational model we use, which is created by linking a document in one collection to multiple documents in other collection. So let's say I have an example of a collection here. Now this is basically widely used, to use increasingly and where there are more array values within a table. So in such case, you can use one-to-many relationship. Now, for example, I have an authors collection which says the name of the author is J.K. Rowling, and we have two different books, and for that we have object IDs as well. So in other collection, we have the details of the books now clearly, which is ID again, and name of the book is Philosopher's Stone, and next we have another book collection, the data that is of Chambers of Secret. Now, in order to combine this, now one-to-many is basically with the reference of author collection. I'm basically connecting, two different book collection into a single document. So we have multiple documents in the books collection, right? And we have a single author collection. Now I'm basically clubbing these two. I'm creating a link between these two collection and I'm creating a single document. So if you look at in the resultant set, I have the name of the author, that is J.K. Rowling, and the books and their IDs and the details of their books, that is the name, that is Philosopher's Stone and Chambers of Secret. So in this way, you can also use one-to-many relationship model in order to properly structure your data based on the requirement. And similarly, we also have many-to-many relationship here, guys, but I'm not going to discuss it. Let us know in the comment section below and let us know what can be a good example of many-to-many relationships. And that brings us to the end of today's session, guys. Now, while embedded embedded document model is ideal for one-to-one and one-to-many relationship, and referenced data document model is ideal for many-to-many relationship. Now, denormalization, which is embedded, whereas normalization is the name given to reference relationships. Now, establishing a good relationship between documents can aid in the refinement of the database structure, as we discussed earlier, which can overall impact the overall performance of the database and can reduce the execution time in the database as well.
We often need to store files in our databases, right? But MongoDB is one such database that doesn't let you store any file larger than 16 MB in a normal document. Instead, MongoDB has a functionality specifically for storing large files, and it goes by the name GridFS. Well, you heard it right. MongoDB becomes much more efficient when combined with GridFS. It divides a document into parts, or basically we call them as chunks, that are then stored as a separate documents. So in a nutshell, GridFS is a kind of file system used to store files in a smaller segments. On that note, hey everyone, welcome to Simplicode's YouTube channel. I hope you guys are doing good and staying safe. In today's session, we'll be discussing about GridFS in MongoDB, how it is used, what is its significance, and how to add documents in smaller segments or in chunks by using GridFS method. So without any further ado, let's get started with today's topic. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel Simplicode to stay updated with all the latest tech content, and hit that bell icon to never miss an update from us. Alright, so what is GridFS in MongoDB? GridFS is one of the powerful specifications of MongoDB that helps to store and retrieve large-scale files. So it is a specification for storing and receiving files larger than 16 MB limit of JSON documents. Now, these files can be structured or unstructured, and they include documents, audio files, images, recorded video clips, binary files, etc. Now, GridFS is similar to a file system for the storage of files, but MongoDB collections are used for storage of data and files using GridFS, which has powerful features to store the files of any format, including files that are even more than 16 MB in size. So in classical implementation, there is a file storage system of 16 MB, but MongoDB GridFS can store and retrieve files beyond this limit too. Now, MongoDB GridFS features allow for the storage of large files as we discussed earlier. So in order to store very large files, it is not necessary to load the entire file into RAM. Instead, chunks of the files are streamed to the database. So these files can be again of any format. It can be an audio, PDF, movie, and then they are converted into smaller chunks and they are streamed into the database. So each chunk is limited to 255 KB in size. This means that the last chunk is normally either equal to or less than 255 KB. So the chunks are partitioned into smaller 255 KB files, and when you read from GridFS, the driver reassembles all the chunks as per the user's requirement when they are needed. This means that you can read sections of a file as per your query range, such as, let's say, listening to a segment of an audio file, or you're trying to fetching a particular section of an image file. Now, because as discussed earlier, files are separated into smaller parts, it is easier to access specific areas of a file, which saves memory tasks such as loading the whole file. Now, let us now understand why we use GridFS in MongoDB. So as discussed earlier, in MongoDB, we use GridFS for storing files which are having size larger than 16 MB. So in some situations, storing large files may be more efficient in a MongoDB database than on a system level file system, and that is a reason we have some reasons, right? A particular significance of using GridFS. One such reason is if your file system limits the number of files in the current directory in the Mongo database, you can use GridFS to store as many as files that are needed. Now, the second reason is when you want to access information from portions of large files without having to load the files into the memory, that is, without calling the whole data into the RAM, you can use GridFS to recall sections, only a particular specific sections of files without reading the entire file into the memory. And finally, if you want to store and sync files and metadata across distributed systems, so when you want to keep your files and the data automatically synced and deployed across a number of systems and facilities, you can basically use GridFS. So MongoDB can distribute files and their metadata automatically to a number of MongoDB instances in the database. So these are some of the reasons on why we use GridFS in MongoDB. So let us now move ahead and understand how exactly GridFS works in MongoDB. Now, GridFS stores files into two collections. Now, these two collections are basically known as chunks and files. Chunks basically stores the binary chunks, and whereas the files store the files metadata. So if you look at this diagram which we have in our presentation that you're looking at, we have, let's say, a large file. It can be an audio, it can be a video file or anything. And let's say we are using GridFS in order to convert into a chunk of files. Now, when you're basically converting into a chunk of file, it basically converts into file metadata and the smaller segments of data which we call as chunks. So we have fs.files collection, fs.chunks chunks collection. So basically GridFX stores files in two collections, right? Now it places the collection in a common bucket. So you can see we have fs bucket, which comprises of fs.files and fs.collection. So it places the collection in a common bucket by prefixing each with the bucket name. So by default, GridFS uses two collection, as you can see, which is fs.files and fs.collection. You can choose a different bucket name as well as create multiple buckets in a single database. Now the full collection name, which includes the bucket name, is subjected to your requirement and the need of the file that you're working on. So let us now understand what is GridFS chunks collection. Now each document in the chunk collection represents a distinct chunk of a file, which is a smaller segment of the initial or the original file, which represents a distinct chunk of a file as represented in GridFX. So the syntax of it, I wouldn't say it has a syntax. Basically it stores the data in a format of ID, files ID, in, and data. So basically a document from the chunk collection contains these following fields. Now the chunk ID, it is basically the unique object ID of the chunk. Now just like how when we store a data, it automatically creates a default ID in our MongoDB database. Similar for GridFS also, we have an ID that is being automatically generated. Next we have the chunks.files ID. Now this is basically the ID of the parent document as specified in the files document. Next we have n. Now chunks.n basically is a sequence number of the chunk that is being stored into the collection. Now GridFS numbers have chunk numbers starting with 0 and so on. And finally we have chunk.data. It is basically the data that it gives a different serial number to the data that we have inserted into our JSON document. Next, we have the GridFS chunks collection. Oh, sorry, there's a mistake. We have next GridFS files collection. Right now, we have discussed what is chunk collection. Now, next we have the files collection. Now, each document in the file collect represents a file in a GridFS. And similarly, just like the chunk collection, we also have a format and different fields. When we try to store GridFS collections in our database. So some of the fields that are present in the collection are ID, length, chunk size, upload date, file name, content type, aliases, and metadata. So documents in the file collection contain these following fields. Now, for example, the ID again, it is the unique identifier for this document, and the ID of the data type chooses for the original document. Next, we have the length, which is basically the size of the document in bytes. Next, we have the chunk size, which is basically the size of each chunk in bytes. Now, basically, GridFS divides the document into chunk size of, as discussed earlier, it is default 255 KB each. Next, we also have upload date, which is the date the document was first stored by the GridFS. And next, we have the content type. It is basically the type of file that you're basically adding to database to store information related to the type of GridFS files. And we also have optional field like aliases, and we also finally have metadata, which is an optional field which may be of any data type and can hold any additional information you want to store. So I hope you understood what is GridFS and how it actually performs, what are chunks, and how it is dividing into segments like chunks and files. So let us now get into the direct execution part and see how it gets executed. Now other than the theory of what GridFS is, it is also important to understand how we can use GridFS to store large files. And you have to remember that as the syntax is an important aspect of executing the GridFS in the MongoDB. So the one thing that you have to remember is in order to query or to insert a file into GridFS, it is not executed through MongoDB shell, guys, but instead of you can use Windows or Linux or Mac command prompt. Now before doing that also, you need to basically download some MongoDB database tools which I'll be showing now. So if you are using Windows, just go to Google and type MongoDB database tools. Alright. Now when you scroll down a bit, you'll have this download MongoDB command line database tools. Click on that. Now, after clicking that, you will be, redirected to another page, which is basically the MongoDB database tool documentation, which will basically show everything about, various database tools that are available. So on the left side, you can see various database tools like MongoDump, MongoStore, BaseOnDump, Mongo Import, Export, and so on. Now we are concerned with Mongo Files, which is the database tool which we are going to use in order to store, data through, GridFS. So just click on that, and if you want to just go and understand what Mongo Files is, you can just read it a bit. So just click on installation here. It will redirect to the installation page. Now you have three options for Linux, macOS, Windows. Click on installing the database tools on Windows, and so it will basically tell you what all to do here. Installation process. It can be installed with an MSI installer or download as a zip archive. Select the tablet depending on your desired installation method. So we'll be basically using the MSI installer only. So open the MongoDB download center here. So I've already downloaded it on my system. So I'm just basically showing you again on how you can install this. Click on download. It shows the version again. Just install the latest version. Platform is Windows and the package is a zip folder. Click on download. It will take some time based upon your internet speed. It will just take some time. So wait for it. Now once you're done, just extract the file. Now as you can see, we have a folder which is MongoDB database tools. And inside that you have a folder named bin. Open on that. Now as you can see, we have the list of all database tools that we have downloaded successfully. Now we are only concerned with MongoDB files, right? So just copy paste this, and now what you have to do is go to the C drive where MongoDB is installed. It is basically in program files. Click on program files, search for MongoDB, click on server 6.0, and you will find the bin folder. Click on that, and just basically paste the whole folder or the Mongo files here. So as you can see, I've already copy pasted the same in my bin folder here. So just click on that, and again you'll be redirected to bin here. Click on that again. So you can see we have the list of all the database tools that we have installed it on our system. So this is basically the location where you have to copy the entire files. Otherwise, it will throw an error, right? So we have Mongo file successfully installed here. Let us now try to understand how to insert a file, with a simple example. So you can see I have, a PNG file, which is an image, which is document one. We also have a video file, which is MP4 file, which is MongoDB replication, it says, right? So let us now try to insert into our database. For that, just click on right click in the same folder. You will find open in terminal. Click on that. So it will open the Windows PowerShell. This is where you have to write the command prompt line. All right. So the above syntax, the syntax that you have to write for this is basically by using the put keyword, which I'll be showing you now. So we'll be just experimenting with one simple example that I've done with a simple image file that we are going to insert now. As you can see, we don't have any specific collection for GridFS files, but as we know, MongoDB has this feature of creating new collection when we insert a document into a non-existing collection. So the following query for inserting a file in GridFS, unlike the insert operation where we'll insert file through Mongo shell, right? Here we'll use the window PowerShell terminal. Now the query to insert data into our database is mention the Mongo files. Mongo files is the keyword, and after that mention the file name. Now the file name that we have taken is document1, right? So mention document1 dot and the file type, which is of JPG. So the above query is basically, this query is a standard format for inserting any file into GridFS. We have basically navigated the terminal to the location where Mongo files, which is a database tool, is being saved. So our query begins with the keyword, which is Mongo files, followed by the storage option, which is put keyword, and it specifies the database where the file is to be stored. And here our database name is generally named as GridFS only, and at the moment we don't have any database with such name, but it will be created. So let us just execute. Click on enter. All right, it is throwing an error. So as you can see, it says we have an error here. It says the command Mongo files was not found but does exist in the current location. Windows partial does not load commands from the current location. Instead type. Okay, now instead of typing Mongo files, let's just copy this and see if it is working or not. Mongo files, again mention the keyword put and mention the document also. I mean the document name that we are trying to insert, which is document1.jpg. Alright, let us now click on enter. I hope it should work now. I'm not sure. So I'm not sure why it is throwing an error, guys. So let's just take another example. We also have MongoDB1, which is again a JPG file. Let us try to add that. Now, basically, if you want to insert data, you have to store the files in this bin folder only. Otherwise, it will throw an error. So make sure you keep an eye on this because adding huge amounts of data can take a lot of time. So if you're trying to insert data which is not specifically in this folder, then it will basically throw an error. So make sure you keep an eye on that. So let's just try to add another folder. Sorry, another file. So the keyword is slash Mongo files. Put the file name is MongoDB1.jpg and semicolon. So click on enter. Well, alright. As you can see in the status, it is connected to MongoDB localhost and it has added grid file MongoDB1, and I think it is successful now. So let's just go to MongoDB shell now and let us see whether or not it is created. So let's just go to let's open MongoDB shell. So as you can see, the shell has started. So now in order to find whether or not the GridFS file is created or not, you have to use the db.fs.chunks.find command. So we can see all the chunks present in the fx collection by using this command. So let's just try to find it. So the command is db.fs.files.find. So click on that. So as you can see, it is retrieving the ID, length, chunk size, upload date, file name, and the metadata, which we have discussed in the earlier, in the presentation slide on what are the different fields that we get. So we can also see the chunks present in the fs.collection related to the stored file with the following code using the document ID in this, which is this object ID, right? So I'm going to use this and try to find how many number of chunks that it has created for this MongoDB1.jpg file. So the query is db.fs.chunks.find, and inside that open the flower brackets and mention the file's ID field which you are trying to find. Okay, mention colon and mention this object ID that has created, which is 639 and so on this, right? Just copy paste that and copy it here and make sure it is in single quotes. All right, let us just close the brackets and the flower brackets as well. Okay, there is an error. Sorry, I just put another square bracket. So I'm not sure why it is showing, but in most of the cases, the query will return the number of documents, that is the whole MongoDB1.jpg file was divided into how many chunks of data, like for example 20, 30 and so on. So in this way, you can use GridFS to store large amounts of files which are more than 16 MB in size in your MongoDB database. Now just to cross verify, go to MongoDB Compass and see how the data in the database has been created. So you can see MongoDB Compass, we have a test database that is created, and we have the fs.chunks and fs.files, which
basically stores the appropriate information of the data that we have created in our database, right? So you can see in fs.chunks, we have ID, files ID, n0, which basically stores the data in sequential manner, like starting from 0, 1, 2, 3, and so on. And next in fs.files, we also have ID, length, chunk size, upload date, file name, and metadata. So that was pretty much all about GridFS in MongoDB. I guess we have covered almost all the concepts. Now, GridFS is basically a gift for developers who wants to store huge files in MongoDB. So if you are someone who is trying to, store data of audio files, image files, or videos files, which is of more than 16 MB, which is the threshold value of MongoDB, which is acceptable rate, upon which only you can use GridFS. So in that case, GridFS storage system allows developers to store big files and retrieve only a certain amount of those files whenever needed. And as a result, GridFS is an outstanding MongoDB features that can be used with variety of applications, which makes it an extremely useful tool for modern applications like a NoSQL database like MongoDB. Let us understand what is MongoDB MapReduce. MapReduce function is widely used to access large data set into a handful of aggregated results, and MapReduce command is used to execute this function. Now, as a result of this, the data is independently mapped and reduced in different spaces before being combined in the function and saved to the specified new collection. This MapReduce function was designed to work with large data sets only. You can perform aggregation operations like max, sum, and average on data using MapReduce, which is similar to that of group by in SQL. So it works independently and in parallel with data aggregation. Now let us understand what are the key parameters in MapReduce. MongoDB provides the MapReduce feature for aggregation purpose. Now generally there are two phases of MapReduce. In the first phase, each document is processed and emits common and redundant part of the document to pass a unique record for the next phase, which is the map function. Next we have the reduce function. In the second phase, all the unique parts get together and aggregate to produce a single result. And finally we have the query. In this, we'll pass the query to filter the result set. So with the help of MapReduce, user can perform like sorting, filtering, and document modification. So let us now understand the syntax of MapReduce. The syntax is followed as db.collection.mapreduce, and within the parenthesis mention the keyword function, and again open the square flower brackets and mention the keyword emit. And as we already discussed that MapReduce works on the key value pair, so mention the key as well as the value that you want to perform aggregation on the data. And then we have function. Again, we have to mention the key and values. This is basically the reduce operation. This is the reduce function we are going to perform here. And then mention the return keyword and the reduce function that you are going to perform. It can be, any aggregation, process. It can be average, sum, or maximum. And inside that we have certain keywords like out, query, sort, and limit. So basically, if you look at the first part here, the collection name, it is basically defined as the retrieve documents from the collection by using the MapReduce command. So we can process large volumes of data using this MapReduce method in MongoDB. So next we have the MapReduce keyword. It is basically a data processing technique which is used for large data and useful aggregated results of large data in MongoDB. And next we have this first part is the map function, guys, and next we have the reduce function in this. You'll get a clear-cut idea on when we get to the execution part, so just have an idea on what exactly we are doing here. So next we have the out keyword here. Out is basically specifies that result location of the MapReduce operation in MongoDB, and we can set output as a primary member, and on the secondary member we can only set an output for this. Next we have query. Query defines the selection criteria of a document in MongoDB. So you are basically telling the operation basically on you are filtering the data on which you want to perform aggregation. And next we have an optional commands like sort and limit. As you know, sort is used to sort the documents from collection. This option is mainly useful for optimization. And also next we have limit. Limit is a specified method that limits the total number of documents in the resultant output.
So I hope you understood the basic syntax of MapReduce model. So let us now go ahead and understand how does MongoDB MapReduce works. Now every input document in the MapReduce operation gets the map face treatment from MongoDB. That is, documents in the collection that match the query condition. So key value pairs are output by the mapping function. Now this map function is used to group all the data based on the key value, and next we have the reduce function. Reduce function is used to perform operations on the map data. So the data independently is mapped and reduced in different spaces and then combined together in the function, and the result will save to the specified new collection. So the reduce phase, which gathers and condenses the aggregated data, is used by MongoDB for keys that have multiple values, and the outcomes are then kept by MongoDB in a collection. So in a nutshell, if I have to tell that, basically you have to mention the mapping function first. You have to define mapping function. Next, you have to define the reduce function to further condense or process the aggregation result. Now the output of the reduce function could optionally go through a finalize function wherein you are performing the complete map reduce function. So let us just understand this with a simple example here. So let's say I have certain collections named as orders. As you can see on the left side, we have 4 different orders having customer ID, amount, status. So we have, let's say, I think we have 2 different unique customer IDs, which is A123 and B212. Now I'm basically querying this based on the status, that is A and D, right? So it is querying and it is filtering the records based on this. So you can see A123, amount 500, status A. Next we have again, which is A123, amount 250, which is status A again. And we also have A123, but the status is D. So it is not considering into a resultant equation. And also we have this B212, which amounts 200 and the status is A. So the query is basically filtering the resultant set in our output. Next, we are basically mapping the function. We are mapping based on the customer ID here. So we have 2 different customer IDs, which is A123 and B212. So and then we are performing the reduce function based on the amount, right? So it is reducing the value into A123 and B212, 2 values, that is 500 and 250. For B212, it's only 200. So finally, if we look at the output, we are performing a sum aggregation here, and you can see in the final resultant output, our document which we have saved in a new collection is being retrieved as ID A123, value is 750, that is 500 plus 250, and also B212, which is value 200, which are saving in a new collection named order totals. So this is how exactly MapReduce works, which is again similar to that of aggregation pipeline method. I'll let you know what exactly how MapReduce is different from aggregation pipeline and when you should be using which method. Now before going into that, let us go into the execution part and see how MapReduce works in MongoDB shell. So as you can see, MongoDB shell has started. So firstly, let us see the databases. For that, I'm using the show DBS command. So again, we'll be using the same Simplicode database. So use Simplicode1, and let us now see what are the collections present in this database. So it will list all the different collections present in this. Documents that are present in this collection. So we'll be using marks, collection for this. To perform MapReduce. So let me just retrieve the values that are present in this. So db.marks.find. Alright, when you press the enter, it will retrieve all the records. So as you can see, we have various fields like ID, name, subject, and marks. So we have like ID 101, name Ravi, maths 94, and similarly we have different subjects like science, history, maths, English, and so on. So we'll be performing MapReduce on this collection and see how it exactly performs. Now what we are going to do is we have to apply a MapReduce operation to this marks collection to group them by let's say subject, and then add the marks scored in each subject. So to process this each input document, we have to define the map function first. This map function basically refers to the document that the map reduce operation is processing in that function. And for each document, the function maps the marks field to the subject and outputs the marks and the both subject and marks together. So let us understand how to how to define the map function first. And the query is written as var and mention any keyword here. It can be map here, or you can even keep it as mapping function 1. You can define as per your own choice. Equals to, mention the function keyword, close the square brackets, open the square flower brackets, and mention the keyword emit. And in that we have to write the function which is used with this dot. So we are performing aggregation on subject and marks, right? So we have to mention these two parameters here. So mention subject comma this dot marks, close the square brackets, flower brackets, and mention the semicolon and press enter. Alright, we have now defined the mapping function first. So next we have to define the reduce function. So the reduce function syntax is also similar. Mention var, again mention the function name as per your own choice. I'm just taking here it as reduce, equals to, mention the function keyword again, and you have to pass two parameters here. Since you have passed subject and marks for our aggregation function, so just pass any two values. It can be of any name. You can take it as key and value, or you can even use subject or marks. So I'm just using the subject and marks again here. Subject comma marks, and mention the open the flower brackets, and you have to return this parameter, right? You have to return this function. Now I want to perform, let's say, the aggregation operation, like let's say sum. So I'll write array dot, since it is a document and we have various fields, I'm just writing the array here, array dot sum, and inside that mention the parameter which you are performing the summation, which is basically marks, right? So just close the brackets and close the flower brackets as well and enter. Alright, now we have also defined the reduce function. Now we are left with only map reduce operation, right? So let us now perform the map reduce operation. So the syntax for that is db dot, mention the collection name, that is marks which we have taken, mention the map reduce keyword, make sure that R in reduce is in capital letters, otherwise it will throw an error. And in that pass the both mapping and reduce function names that you have taken. So we have taken it as map comma reduce. So it can be any name that you have chosen. It can be like mapping function 1, or as I've said earlier, it can be any name, but make sure you're passing the same value that you have taken. And mention the comma again. And in the flower brackets, now we have to mention the keyword out, as we discussed in our syntax previously. And now you can give any collection name to your output resultant set. It can be of any choice. So I'm just naming it as the result here. I think it will be good to go. So let me just execute the statement. All right, it is throwing an error. Collection.map reduces deprecated user aggregation instead. Okay, I'm not sure why it is showing that, but we can see result. It is saying OK1. That means it has been successfully executed. So let us now see whether or not the aggregation function, that is summation, has been performed or data set or not. So for that, I'm again using the find command, db dot, mention the collection name that you have mentioned inside the parameter and map reduce operation, db dot result dot find, enter. As you can see, we have total 4 subjects and the summation values are showing as 93, 96. I'm not sure why it should perform the summation operation. So let's just check. For history we have 93, and for history again 96. All right. So it is showing simultaneously, side by side. It shouldn't be like that. I'm not sure why it is showing in this way. So let's just try to perform another operation and see whether it is showing for them as well. I'm just performing an average operation here. All right,
let me just check. Okay, we have that passed out. Let me just perform the map reduce function as well. Just copy paste this, and you can just change the name as result1. Okay, and click enter. I think it's created. So let us find again db dot which is again result1 dot find. Well, I think there is some issue with the backend of the MongoDB database. I'm not sure why it is throwing an error like this, because average value should be like this average of 40, let's say 93 and 96, right? 49 and 47. It's showing in a different way. For maths, it's 98, so its average is 49, and for 94, it's 47. And the combined value we have to get, but I'm not sure why it is throwing that error. So we'll get back to you guys, but the syntax and the execution is the same. I think there is no mistake in the syntax that we have written here. It is same. There might be some issue with the backend, so we'll just get back to you again. So stay tuned for that. And well, I think that's all about MapReduce. We have discussed almost everything. What MapReduce is, its syntax, how it works, and how how it is used, instead of aggregation. And that brings us to the main question on, which method you have to be using, whether it's aggregation pipeline method or it is MapReduce, function. Now, complex queries are difficult to handle in aggregation framework. It can be useful, but I would say it is not recommended for complex queries. Whereas if you take small data sets will take a long time to load in MapReduce. And even large data sets will take the same amount of time to process. Now, whether or not the data set is small or large, it will take the same amount of time to execute. So as a result, large data sets should be handled using the MapReduce functions always, and it is a recommended option. The MapReduce function can handle large data sets more quickly due to its maybe its flexibility over large data sets. So you can always use this while you're handling large volumes of data. And on the other side, you can use the aggregation pipeline to handle small data sets, for regular usage when you're performing small calculations that is present in your, documents, that is present in your collections, I would say. So this is how both aggregation and MapReduce are different from each other and when you have to use them. And I hope you understood that as well.
Also, if you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who likes to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM. The link in the description box and the comment section should navigate you to the homepage where you can find the complete overview of the program being offered.
So let me start with this. So again, I told you that the master-slave replication was something which used to happen earlier, and it gave way to something called replica sets. So the master-slave replication is the oldest mode of replication that MongoDB supports. In the earlier versions of MongoDB, the master-slave replication was used for failover, backup, and the read scaling. In the newer versions, it is replaced by replica sets for the most number of use cases. Here you can see there is a master and there are slaves attached to that. So replica sets are recommended for new production deployments to replicate data in a faster rather than a master-slave architecture. So again, how does a replica set in MongoDB works? So a replica set consists of a group of MongoDB instances that we just saw that host the same data set. That again we saw. The replica set functions as follow. The primary MongoDB receives all the write operations, and the secondary MongoDB replicates the operations from the primary. This is something that Sandeep would have seen in a live working on his replica set. The primary node receives the write operations from the clients. The primary logs any changes or updates to its datasets in its oplog. The secondaries replicate the oplog of the primary and apply all the operations to their datasets. So replica set in MongoDB. An extra MongoDB instance can be added to a replica set to act as an arbiter. So what is an arbiter node? So this is specifically added to the replica set so that the total number of instances we can have can be odd, so that if in case the primary goes down, we can have a majority if an election takes place. So following are some of the characteristics of an arbiter. So arbiters do not maintain a data set. Arbiter is the node which just participate in an election to select the primary node. So the only purpose of it is to take part in the election. It doesn't even store the data. So again, arbiters do not require dedicated hardware. Again, it can just work as a command prompt, as we have done in our systems. Secondary members in a replica set asynchronously apply operations from the primary. Important point to be noted over here is asynchronously. It's a lazy write. These replica sets can function without some secondary members. As a result, all secondary members may not return the updated data to the clients. So again, when I told Sandeep that you make a write to the primary or an update to the primary and see the data back in the secondary. So you guys would have seen again that you are not able to see the data over there in the secondary. It'll come after some time because again it's a lazy write to the secondary. So a primary can convert to a secondary or vice versa. However, an arbiter remains changed. Automatic failover. So this is something which talks about the replication in detail, and what it talks about is when the primary node of a replica set stops communicating with other members for more than 10 seconds, another member is selected as the new primary. Selection happens through an election process. The secondary node that gets majority of the votes becomes the primary. A replica set supports application needs in the following ways. Again, deploying a replica set in multiple data centers, manipulating primary election by adjusting the priority of the members. So that's what again, when we initiate an instance, I can also, when I specify the config, I specify the config, again ID the members, along with that I can specify the priority as well, that if the priority of the guy will be more, I can ensure that whether the secondary will be able to become a primary ever or not. Supporting dedicated members for functions such as reporting, disaster recovery, or backup. So again, we can see in the diagram that the primary goes down. What happens is election for a new primary happens, and again we see that the new primary is elected. One of the secondary becomes the primary, and the other secondary just follows what the primary says. Again, replica set members. A replica set can also have an arbiter. Arbiters do not replicate or store data, but again play a crucial role in selecting a secondary to take the place of a primary when the primary becomes unavailable. A typical replica set contains a primary, secondary, and an arbiter. So again, what we see is we have a primary node, we have a secondary node, and we have an arbiter. And you can see there is a heartbeat going constantly between all the nodes. Again, this heartbeat is on the similar lines, what the heartbeat we see in Hadoop. In Hadoop, we see all the secondaries, that is the data nodes, share a heartbeat with the name node. So again, like this, all the nodes over here in MongoDB as well share a heartbeat among themselves. A replica set in MongoDB version 3.0 can have maximum 50 members with only 7 members capable of voting in the election. So again, now we are specifically talking about who are priority 0 replica set members. Again, when we set a member a priority of 0, what will happen? That will be a secondary which can never become a primary. So again, a priority 0 member is a secondary member that cannot become the primary. The characteristics of a priority 0 are: it cannot trigger any election, it can maintain dataset copies, accept and perform read operations, and again choose in electing a primary. So again, he can vote an election, though he cannot trigger an election. So by configuring a priority 0 member, you can prevent secondaries from becoming the primary. In a 3-member replica set, one data center hosts both the primary and the secondary, and a second data center hosts one priority 0 member. So again, I've just kept one copy of the data in some other data center just to ensure if the full data center goes off, I still have some data with me safe in some other data center. A priority 0 member acts as a backup and can immediately replace an unavailable member in a replica set because again it has the data. So always we recommend that we have a priority 0 replica set member as well in our replica set. Now we have something called hidden replica set members. Again, hidden members are those which are not seen to the client. What again that means? Hidden members of a replica set are invisible to the client applications. The characteristics of a hidden member are: they store a copy of the primary's data, they are priority 0 members. Again, they mean the moment you see priority 0, the main thing which should come to your mind is it's a secondary and it cannot ever become a primary. Their priority 0 members can elect a primary but cannot actually become a primary or replace a primary. They are not given appropriate read and write rights. They can be used for dedicated functions like reporting and the backup. So there's something you see, there is a primary, there is secondary, and again there is a secondary guy whose priority is 0. Then there are some, replica sets. Again, an important thing which, is asked in the interviews quite often. What are delayed replica set members? Again, I can even set some members in a replica set with a delayed, I can specify that, you start copying the data from the primary after these particular minutes. So those are called delayed replica set members. So again, delayed replica set members are secondaries that copy data from the primary node's oplog file after certain interval or delay. Delayed replica set members reflect a previous version or delayed state of the stored data set. It's like, I create a backup of the data after some T hours. What happens is, in case of a failure or something, I can again make the system come back from whatever time it was earlier. So delayed replica set members are secondaries that copy data from the primary node's oplog file after a certain interval delay. Delayed replica set members reflect a previous version or delayed state of the stored data set. So again, what I was saying to you guys was, very importantly, they are basically used so that we can checkpoint some data, so that if in case of some failure, I can still bring the data back to the system to the place it was earlier. So delayed members perform a role backup or run a historical snapshot of the data set. They help manage various human errors and recover from errors such as unsuccessful application upgrade and drop databases and collections. The characteristics of a delayed member are as follows. It must be a priority 0 member. It must be hidden and not be visible to applications. It again must participate in electing a primary. Now again, we can see over here, what is this? So what we're talking about is, you can configure a delayed secondary member with the seconds given below. So again, delayed secondary member, it again has to have a priority value of 0, which again means that it is a secondary which cannot ever become a primary. Hidden value is true, it means it will be hidden. And again, slave delay value means, again, how much seconds you want the system to wait till it makes a copy of the oplog. To set an 1 hour delay, issue the operations given below. Again, you can see over here what we are setting is, we are setting a configuration. So config is equal to rs.conf. And again, what we give over here is config.members 0.priority, we are giving is 0. Again, members. So again, please see that, what you see over here, the members you see over here is the array which you had in your configuration. So the first member, his priority I'm setting is 0, his hidden I'm setting is true, his slave delay I'm setting is 3600. And again, after I've made some configuration changes, I can reconfigure it.
Alright, as you know that MongoDB relationship represents how multiple documents are logically connected to each other in MongoDB. It provides two types of relationships, namely embedded and referenced. Embedded documents capture relationship between data by storing related data in a single document structure. On the other hand, reference models store the relationship between data by including links or references from one document to another. Now, to implement a normalized database structure in MongoDB, we use the concept of reference relationship. That is, if you look at the left side of the screen here, you can have an example where it is a reference model where we have student collection and inside we have ID, and then we have another document contact details where we are referencing using this student document, right? So in that way, we can use reference model for that. So we use this concept of reference relationship, also referred to as manual references, in which we manually store the reference document ID inside another document. Now, what if the data that you're trying to search isn't present in different collection or in different database? And that's where you have to use DBRefs. DBRefs are references from one document to another using the value of the first document ID field, collection name, and optionally its database. DBRefs basically allow you to more easily reference documents stored in multiple collections or database. So if you look at this example, I have a user collection here and a post collection here. In the user collection, I have ID, name, post as my fields, and I'm trying to fetch those from the post collection, which is another collection in in that case, right? So if I'm trying to retrieve data from another collection which may be present in another database, in such case you have to reference the database that you're trying to search for, and that is where we use dbref. So, and that brings us to the main part. What is, MongoDB database references? MongoDB database references allow you to more easily reference documents stored in multiple collections or database. So relationship between documents can be represented using this dbrefs, which offer a standard format and type. So if a database needs to communicate with a variety of frameworks and tools present in MongoDB database, the dbref format offers common links for representing the data between the documents. However, in cases where a document contains references from different collections, in that case we have to use MongoDB derefs. So it basically represents a document rather than a specific reference type. And if you're trying to find data in more than one collection, in such case, you have to use MongoDB database references. All right, I hope you understood what it is, and let us now move ahead and understand the various parameters that we use, while writing, database reference syntax. First, we have the $ref keyword. Now, ref field basically holds the name of the collection, where the reference document resides. Next, we have the ID field. The ID field basically contains the value of the ID field in the reference document. And finally, we have the optional DB, which contains the name of the database where the document or the reference document resides. So in MongoDB, these are the three important fields which should be used in order to implement dbrefs relationship as follows. Let us now understand the syntax of MongoDB database reference and how it is exactly used. Now let's say if I have an address collection here, which I'm basically creating two different fields, which is ID and city. So the command is the db.address.insert, and ID is 145 and city is Bangalore. Next we have another document which is db.address.insert, which is the ID is 124, city is Delhi. So firstly, we have inserted two documents in our address collection. Now let us move ahead and see and how we can implement this using another collection which might be present in different database. Now let's say if I have another student collection, and I'm inserting records, wherein I'm inserting records of student details like ID I'm providing as 1, is first name of the student is Rahul here. So as you can see here inside the address ID, which is the database reference field, which is part of the document or the collection, student collection present in this collection, we are using MongoDB reference approach to refer the address ID present in another collection which we have taken from the address collection here. After defining three fields which are basically ref, ID and optional DB. So the ref is basically we are providing the field which you want to reference, provide a reference to the collection that you are trying to connect here. So earlier we mentioned the ID and the address in the address collection, right? So I am referring to that. That's why I'm providing the collection name as address and ID as 105, and database is optional. You can keep whatever you want. I'm just taking simply it as simply code 1. And similarly, we are again inserting another document, and again we are referencing it with the dbref ID, dbref field, which is again address ID. And for reference, I'm taking again address collection and ID as 124 and db.simplycode. Now you might have a question now, what exactly and how exactly MongoDB dbref works here. Now the syntax is followed as var student db.student.find1, which we use in order to find the data. Now I'm trying to search the first name with the name of Rohan. So I want to get the details or the address of this student whose name is Rohan. So for that, I'm querying as var student address equals to student.address ID. And after that, mention the syntax as db within the square brackets student address dot $ref.find ID, where student address dot ID. Now what does it mean? So I'm basically connecting both the address collection and the student collection, and that is what I'm referring here, student address dot reference and student address dot ID. So in order to get the address of the student Rohan, you have to basically provide a reference to both these collections. So that is what I'm doing here. So when you execute this statement, this will be the final output. Now for Rohan, we have the ID which is 145 and his city, the address is Bangalore. So this is how exactly dbref works in MongoDB. And that brings us to the end of today's session, guys. In this tutorial, we have revised the concepts of data relationships in MongoDB with the likes of manual references used for data modeling in the MongoDB, and compared it against the concepts of MongoDB dbrefs, where the former is used when the references are to be made to the documents present in the same collection. So you can use manual references when you're trying to make references in the same documents or which are present in the same collection. And the other part, which is MongoDB dbrefs approach, is used when the references are to be made to the documents present in different collections and in different database. Now the main question comes is, why is no longer MongoDB dbrefs concepts is not used? It is deprecated all around the world, and it is not a suggested method when you are trying to work on this MongoDB database. And that is the reason also MongoDB documentation recommends manual references unless you have documents referred to in multiple locations or the collections in a database. So when you have multiple collections for your references to target, we would highly recommend, it's still easier to store the object ID and collection name in the own object without specifying or with a special name of dbrefs, and that won't break if someone insert the field out of the order. Now, although dbrefs haven't been deprecated in MongoDB as such, and the functionality is unlikely to go away, but hopefully you can see there are good reasons on why to use and how to avoid this function that we have discussed in this tutorial.
So why Python, MongoDB? We understand MongoDB is one of the most important database, which is so-called document-based database available in market, and it is fantastic, phenomenal in terms of speed and the reliability. It is purely called NoSQL database, okay, and helps you to go schemaless. Now, Python is one of the most commonly user-friendly programming language for creating a complete web-based framework. So it offers you huge amount of libraries with flexibility of connecting wide variety of applications. So we would like to give you the idea of like how Python and MongoDB works together. Okay, so you can use both the products together to develop different varieties of applications which can suit to different type of ideas. Now here we have one of the very popular tool available named called PyMongo. So PyMongo is actually the Python library, which is a kind of a driver through which you will be able to connect with your MongoDB and perform basic operations whichever you expect. Okay, so let's go ahead and start working on those demos. Okay, so we will start with creating a MongoDB environment with cluster in one of the very popular tool that is known as called MongoDB Atlas. So we'll be opening our website and go here and talk about called MongoDB Atlas. I search for MongoDB Atlas, that is basically the MongoDB where called database as a service. I'll be selecting the first option and go to the start free because it's going to offer you by default some 500 MB of free space. I say sign up with Google. Going ahead and selecting this. Okay, I say accept and say submit. Okay, so it is starting up now. It'll ask you about a few things. I would rather say to select skip and continue. Well, it'll ask you about which environment you would like to take. So I like to take this shared cluster. I say create cluster. Now here it will take a while to get yourself ready for. We can see it is offering the sandbox of having 512 MB of free space. And this MongoDB, no backup, that is the by default cluster name. You can give the name of the cluster if you want, but let it be by default cluster 0. I'm saying create cluster. So my cluster is being ready. So it will take a while to get your cluster set up. So just wait till the time your cluster is getting ready. So I tell you about this cluster is going to give you by default 2 child and 1 parent, so called a 1 master and 2 child nodes where your cluster will get ready. So You really don't need to set up any kind of cluster in your local environment, and that is the best environment I would suggest for most of your development, where your time reduced. There will be no software requirement because sometimes version to version it changes, and you can get all the benefits of clusters. So we're just waiting till the time the cluster is getting ready. So once the cluster is ready, you will be seeing some options where will help you to create the clusters in your upcoming demos. So friends, your cluster is now ready. You can see now in this cluster you have got this environment. So in this environment you will see there are some options they have given you one by one. Build up your cluster, create a first database user, add an IP address, multiple options they're telling you now. So how to set up? So the first build of the cluster, which we have anyways done. Next is called create your first database user. So select this. So it will highlight this area. Now you can say like database access, and I'm going to create a first new database user and new database user, giving the username called admin. Let's keep very simple username and password admin123. So admin123. Yeah, same, and say add user. Now you can see the user is created. Now let's go back to the next option. It's telling me the network access. Now go here and say, sorry. Now say add IP address, and I'll say allow access from anywhere so that I can take it from anywhere. I say confirm. Now it is telling me about the progress. I select this. Now tell me about which type of collections you want. Okay, so I select this, and inside this I'll be selecting this called collections. Okay, and it's getting ready. So it is giving me some options. Well, two options it will give you: load sample data set, add my own data. I'll say add my own data. Give the database name SL demo. Give the collection name EMP or employee. Remember, database name SL demo, or I can better give the name called SLDB. SLDB and employee. I say create. That is getting ready. Okay, so my database and table is ready. That's it. So I think we are all set with this environment. Okay, well, once it is ready, your collection is also ready. I'll go back and click on my project 0, and here, yeah, so once it is there, then I'll be clicking on this option called connect. Now it will give me the multiple options how to connect. So it will say connect with the Mongo shell, or it will say connect with your application, connect using Mongo Compass. I'll select the Python version 3.11 or later. So certainly I'll be using those version only. Okay, and in this I'm having this, so I will be using this to connect with my backend. So that's how exactly you have the setup of MongoDB cluster. Everyone, so we are all ready now with our setup. Cluster we have already created earlier. You remember about we have taken Python 3.11 or later. So here if I just go back and check, I have a got 3.8.5, which is Python 3 version, which is available. So you can select based on whichever we have it. Say 3.11 or later, we can say 3.6 or later. So there'll be no much difference if I just see. Even if I just talk about 3.4, there's some change, but here 3.6 or later, it is same. So I have a 3.8.5. Okay, so I can use the same option. So here in my VS Code editor, I am using for my development. So here's a simple demo.py I have used. Welcome to check if it is working fine. So yes, it is working fine. I'll start working with my first program with MongoDB. So I just go back and say demo py, or I can say py demo.py. Okay, and here if I want to go back and start working on the development, remember one thing, we need first dependency called pymongo. Okay, what I need? Pymongo, and for this we have already installed this dependency here some time back. This is how you need to install. Okay, so we have this statement name called what? Pip install pymongo. That is the first dependency which you need to download in order to work with this. Okay, so that's what we have taken, this install pymongo. So if you just see, you can go back and start developing this statement. Okay, so let's go back and start working on this. Step number one, you need to always say import number one. The one dependency which you've installed is called pymongo. So you can just say pymongo. That is a dependency we have recently imported from. Okay, let me go back and search from next point. So import pymongo from here. We are saying pymongo. Okay, pymongo, and we're also saying import mongo client. That's the first thing you need to remember. Okay, after that we would like to go back and use the cluster. So we say cluster equal to mongo client, and here I'll be passing the complete values, the one which we have taken. So this complete line, I just take it, go back, and here I'm pasting it. Now here I have to basically replace this password with admin123. Okay, and we are all set. Okay, now once it is ready, we can go ahead and define db equal to cluster and provide which database you're talking about. Okay, so you remember about we had a database which was available to us that is known as called SLDB. So I can just use the same SLDB there, and accordingly I can use which collection I'm connecting it to. So accordingly I can go back and insert a record. Okay everybody, so I can see I have got this file with me. Going forward I have to tell, so this is what exactly the connection URL you have received. Now I have to define which database you're working on. Let me say db equal to cluster, and we have to provide in double quotes the database name called SLDB. If you remember, we have used this. After that, we have to mention which collection it was. So collection equal to db, and here we just give the name called employee. That was our collection name. So once it is ready, then I have to basically perform some insert operation. So I just say post. Okay, it's just a name equal to, and here we just provide the properties like I would say name. So it is a JSON based database, so I can just use the name. I say Amar, and once again I can just say email and say amar@email.com. That's it. So this is just the data which I have. Now I want to insert, so I can certainly say collection dot, because I want to insert only one record. You can see I have one functions coming up, collections dot insert one, and pass post as a parameter. Now we are all done. Let's try to run this. So I'll be running this with Python 3 pymongodemo.py. Hit enter. Now It's done. Let's confirm. Here into my code, I will just go back and check here inside my applications. I can just go back to my collections and in employee. Yeah, there we go. We have got some records coming up here. Okay, so these records are nothing but the one which we have recently inserted in our application. Okay, so fantastic. So first example is working perfectly fine. How we can have the records coming from the Python and insert it there. Like that, I can have as many number of records I can add it. So how we can basically add, if I want to add more than one records, let's see this now. Here, in case if I want to add more than one records, so I can just use call post one. I copy this URL and paste it below, and I say post 2. I say Amar, I say Amar G, email amar12@mail.com, and rather than saying insert one, I can use insert many, and inside this I'll be using this square brackets and pass post 1 comma post 2. That's it. Okay, so let's change the little name because it's already there. Let's insert. Yeah, records are inserted. Let me verify once again by refreshing it. Well, now we have a total number of 3 records are available. Yeah, there we go. So records are added. Perfect. So like this, you can have as many number of records you can basically add it. In a similar one, the way we have basically used this, I can also perform the search part too. Okay, so in case if you want to perform the search part, we have a very simple statement available with us. What? I'll go here the way we have added this. So in this, I'll just these records which are added inside my application, I would not execute this. Rather, I would like to go back and say um, no, they are basically commented now, and in fact I would like to use this also. Okay, I'll go here and find results equal to same collection dot find. If I want to find a name, we can just use curly braces name colon Amarche. Okay, so let me say print and pass results. Okay, let's run this. Okay, so it will print what the results for me. Okay, so it is just printing what the cursor object for me, saying like, hey, this is what the record is available to me. We can also change in case if we do not think the correct result is coming up. We can also go back and we can use some alternative option that is called for. Okay, so what we can do, let's take a look here. We can use for. With this for, I can say result. Okay, in results and print this result. That could be one option through which you can get the details with you. Okay, so what you can do, you can run this code again. Oh, I forgot to put this semicolon here. Or we need to check. Well, that was my requirement was. So I'm having this. Let's try to run this. Well, I got my result, and this is what the detail which I have available to me. So very simple how you can basically find a record and how you can basically retrieve the records. At the same time, if you want to have the specific field rather than all the fields, so here in my code, in this result, okay, you can just put a square bracket and tell which field you really want it now. Suppose if you just want ID, or else if you want name, you can basically pick that up. Okay, so if I just want that ID, only ID is printed. That's it. Okay everyone, so you have seen, like in my previous code, how we were basically trying to fetch all the records. We were using this find. Now in a similar line, you can also have the option available, because see, when we used to talk about called find, it gets me lot many records, fine, and because of that we were using this loop. But in case if you want to fetch the individual records, I'll be clear. So in such cases, you really do not want to use find. You can just use find one. So what you can do is, rather than using find, I can also use one more option called find one, and for which I can come back, just remove this all. Yeah. So here in this case, rather than using this find, I can use find underscore. You can see this option called find one. Here we talk about which are the properties you want to skip and which are the properties you want. So I can just use this option called underscore ID, okay, colon 0. Okay, I just remove this underscore ID 0, and here just print what results. That's it. Let's run. So that will try to fetch some of the records for you, because if you do not have that ID which you've overridden, it will certainly not found. That depends on what you would like to take. So if I just say is having some issues, but no problem, but you know it very well how it basically takes. Now in a similar line, we would like to also perform one more activity to talk about delete. So for which what I will do is this, I just want to uncomment it. Okay, and I would like to insert some records here. So here I want to add the ID by my own with name. So we already have this name. Email, I have it. I would like to use underscore ID. Okay, so we have this property underscore ID colon 101. Okay, comma, like this. Copy the same, using it here, and this time I'm using 102. Name and everything, it'll be taken. Let me say user1. Here we try to say user2. Okay, so collections dot many result find one. I'm just deleting it all, and let's try to execute it first. Okay, so it's executed. Going back. Okay, so I have some records with ID 101 and 102. Now here I just delete this and perform some actions here. Here we say results equal to collection dot delete. See, the options are available: delete one and delete many. It totally depends on what you really want. Okay, so if I just talk about called delete one, it will be only deleting one record. Delete many means where the matching records are available, you delete it. Fine. So I'm just using this option called delete many. Okay, wherever the property names are matched, cause quite possible names sometimes match or whatever it is. So it's delete many. So the option is up to you now how you want. So the selected name you have to offer it, whether you want to match it with the name or whether you want to match it with the email or whatever it is. So that will be offering it. But there's also an option available where you would like to delete everything. Are we clear? So if you're planning to delete it everything, what you can do, you can just leave it as a blank and try to run this. So collection dot delete underscore many. Let's check. Great. All records are deleted. So as I told you earlier also. So delete many means what? It will delete all the records whichever are present in your code now. Clear? In a similar one, if I want to perform insert, so you remember about we have an option called what? Insert many, and here we would like to pass post 1, post 2. Let's execute. So it will add the records inside this. Okay, and next time what I want to perform after adding this record, I would like to perform the update part. Okay, so what I really want in my update, let's take a look. Update means certain properties I'm looking forward to be get updated. Okay, so in case if I want to check whether record has to be updated, I would first go and check whether the record does exist or not. Yeah, we have two names, user1 and user2. Let's go back and update part. Here I just say collections, okay, dot update one, update. You can see update one here. Very simple functionality. Here you will go and tell which ID you would like to perform an update. So I say underscore ID colon. Which ID you want to consider? I'm saying 101. Okay, and what else? So I just use another curly braces and I say, sorry, dollar set. And after this, I use this colon, use the curly braces, name, okay, and use what name you want to use it. So suppose there is a user one, I'm saying user 123. Okay, let's see. It is loading and you can see the record user 123 is updated. Perfect. So your code is absolutely working fine. So you talk about either insert, you talk about what update, you talk about anything, it works. So insert, update one, delete one, insert one, as the name suggests, they'll be taking care about inserting, updating and deleting one records. But the moment you use many, they'll be performing multiple records. So this is a very simple way like how the Python will connect with your MongoDB.
Indexes help perform the following functions: execute queries and find documents that match the query criteria without a collection scan. Limit the number of documents a query examines. Store field value in the order of the value. Support equality matches, which are again a range-based queries. So again, we need to see over here that MongoDB indexes are similar to the indexes which we use in any other database. So these are different types of indexes which we see, and the different types of indexes we'll see in MongoDB are. So by default, the underscore ID we have, that is by default indexed. So each MongoDB collection contains an index on the default underscore ID field. So we can have a single field index. It means a single key on which we want to put an index. So for single field index, and sort operations. MongoDB can traverse the indexes either in the ascending or the descending order. So that's again why the 1 and the -1 came into picture. So it can do in both if we are talking of a single field index. Then we come across compound index. So MongoDB supports user-defined indexes such as compound indexes for multiple fields. So now if I want to put a compound index on the name and the age together, so what is the way out? So the way out is again putting a compound index on both the name and the key. So when we are putting a compound index on the name and the age, I have an option that I can make the name index sort in an ascending manner and make the age index sort in a descending manner. Then we have a multi-key index if we have more than that. So this is basically used for indexing array data. Suppose we have an array called hobbies, and hobbies again have 3 things called say TT, badminton, and say volleyball. And what we see inside that is internally what Mongo does. Mongo will create an index for every value inside that array. So it will create a different index for hobbies.cricket, hobbies.tt, hobbies.badminton. So that's a multi-key index. Then we're talking about a geospatial index. So again, we will talk about the geospatial queries as well going down the lane. And then we have something called text indexes. So when we say geospatial indexes, that means that we will be able to assign a latitude and a longitude to a particular document. So if we talk about, say again, let's talk about something called, there is a collection called Ford dealership. So again, Ford dealership, F-O-R-D, Ford is a brand of a car. And again, if we are looking for servicing our Ford car in some service station, suppose there is a collection which has all the details about all the Ford dealership centers there are in Bangalore. Let's take the example of Bangalore. So now, along with every document containing information about every single authorized Ford dealer, it will also contain a latitude and a longitude which will tell the location from which that particular document is associated with. So after that, so again, in that, if we want to if we want to put an index on some particular key, we will call that a geospatial index. So indexes used in geospatial queries are called geospatial indexes. So we can use 2D indexes and 2D sphere indexes. So we'll talk about both of them when we see down of them in detail. Then we have something called text indexes. So it searches data string in a collection. Then we have something called hashed indexes. So MongoDB supports hash-based indexes and provides hashed indexes. So moving to the next slide, we have a single field index. So now we'll see every type of index in detail, what it has to offer to us. So now single field index. So MongoDB supports indexes on any document field in a collection. By default, the _ID field in all collections have indexes. So that's what I already told you. Moreover, applications and users add indexes for triggering queries and performing operations. So MongoDB supports both single field as well as multi-field indexes based on the operations the index type performs. So here we are, what we're doing is, there is an items collection, and what we are specifically doing, we are creating an index on the item key in the items collection. So this is another way how to create an index. So we can also do db.items.ensure index. So both of them will result in an index creation in our collection. So either db.collection.createIndex or db.items.createIndex. Both of them will allow us to create an index. Moving on to the next slide. So single field index, if we want to have on an embedded document, how we can do it. So embedded document is something which we talked about yesterday. So we can index top level fields within a document. Similarly, you can create indexes within embedded document fields. So we can see we have a document where what we have is we have a guy whose ID is 3 whose item is book, and available is true, and sold quantity is some number, the category is NoSQL, and the details is another document internally with ISBN as publisher, and the ISBN is 1234 and the publisher is XYZ company. So again, in this, what we have done is we have just created an index inside embedded document. So we had a details document embedded inside a normal document. So we were able to create an index specifically on that using a dot operator. The command shows db.items.createIndex details.isbn:1. Now what this shows, so MongoDB supports compound indexes to query multiple fields. A compound index contains multiple single field indexes separated by a comma. The command shown on the screen clearly suggests that it's an example of a compound index on two fields. The diagram depicts a compound index for the fields user ID and score. The documents are first organized by user ID, and within each user ID, scores are organized in the descending order. The sort order of fields in a compound index is very crucial. The documents are first sorted by an item field value, and then within each item field value, they are further sorted by the stock field values. So for a compound index, it is imperative to know that MongoDB limits the fields of a compound index to a maximum of 31. So we can't have more than 31 keys take part in a compound index. So now we talk of index prefixes. So index prefixes are created by taking different combination of fields, and typically they start from the first field. For example, consider the compound index given on the screen. It has item in the ascending order and available in the ascending order as the index prefixes. So MongoDB uses a compound index even if the find queries are for index prefixes fields. It uses indexes for querying the item field, the available field, and the sold quantity field. So very imperative to note over here, the MongoDB cannot efficiently support the query on the item and sold quantity fields by using index prefixes, as it would be like using separate indexes for these specific fields. The item field is a part of the compound index and the index prefixes. Hence, the item field should be used in the find query of the index exclusively. Now here we come to the sort order, which we talked about some time back, the 1 and the -1. Again, an important thing. In MongoDB, you can use the sort operations to manage the sort order. So you can retrieve documents based on the sort order in an index. If you're unable to obtain the documents sorted from an index, the results will actually get sorted in the memory. Sort operations executed using an index show better performance than those executed without using an index. So again, as I told you, the scanning of documents, how much of they get scanned. So if we have an index, definitely there is a performance improvement over that. In addition, sort operations performed without an index gets terminated after exhausting 32 megabytes of memory. So typically, indexes store field references in the ascending or the descending sort order. So for single field indexes, MongoDB can traverse the index in either direction, that is either ascending or the descending. Hence, the sort order doesn't actually become important. But when we talk of the compound indexes, the sort order becomes important because as it helps to determine if the index can support a sort operation or not. Now, the next thing which we have over here, we need to ensure that we don't end up making too many indexes. So that's why the heading you can see in red, ensure the indexes fit in the RAM. So all of you, I'm not very sure again, whether you guys are aware of this or not, but MongoDB is a in-memory database. When I say it's an in-memory database, what I want to say, it again brings the data process first of all into the RAM and then processes that, and thus we get faster efficiency. So if there is a chance there is a data set not in the RAM, because again all of our data cannot reside in the RAM, what will actually happen is it will incur a page fault. In operating system we would have read something called page in and page out. So if there is a page which is required by MongoDB to be processed right now, and if that page is right now not in the RAM, what the Mongo will do, it will do a page in from the hard disk to the memory, but that will again cause a separate overhead to get that thing done. So too much of page fault is something which is not recommended. So that is the reason we see over here that we need to be very sure that all of our indexes fit in RAM and we don't end up making too many indexes. So to process query faster, ensure that the indexes fit in your system RAM. This will help the system avoid reading the indexes from the hard disk. That's again exactly what I told you. To confirm the index size, use the query given on the screen. This returns the data in the bytes. To ensure this index fits your RAM, you must have more than the required RAM available. In addition, you must have RAM available for the rest of the working set as well. So for multiple collections, check the size of all the indexes across all the collections. The indexes and the working sets both must fit in the RAM simultaneously to get a better query. So again, if the index field contains an array internally, so it's again Mongo which decides whether it'll create a multi-key index on that or not. So what we have over here is multi-key indexes. So when indexing a field containing an array value, as we know, again multi-key indexes. I told you the example of hobbies. It has TT, badminton, and say volleyball. So MongoDB what it will do, it will create separate index entries for each array component. So MongoDB lets you construct multi-key indexes for arrays holding scalar values such as strings, numbers, and nested documents. So to create a multi-key index, use the method given below. So again, that's exactly what we were using even earlier. So db.collection.createIndex or insert index, both of them will work. So again, we need to know that if the index field contains an array, MongoDB automatically decides whether it really needs to have a multi-key index being created or not. So this is something which the framework decides implicitly. So compound multi-key indexes. So in compound multi-key indexes, each index document can have maximum one index field with an array value. With more than one field contain an array value, compound multi-key indexes cannot be created. So given below is an example of the document structure. So what we say is the ID is 1 and the product ID we can see it is an array which is having the value 1, 2. Similar way retail ID, another array having the value 100 and 200, and then we have a category which is having a normal string. So a shard key index and a hashed index cannot be a multi-key index. So we'll see down the line, what is a shard key. We have not come across sharding, so we will understand that once I guess this is something which I told you in the second class, or I guess the first class, that we shard our data across multiple clusters using a shard key. The way we had block size in Hadoop, which ensures that the data file gets divided into blocks and then it gets scattered across the cluster. Similar way, shard key is the thing over here which ensures that what happens, it shards our data accordingly. So the shard key, suppose we have an employee collection, the perfect shard key will be employee ID. So I can make the first 20 records reside in the first cluster, the next 20 somewhere else, and the next 20 somewhere else. So a shard key index and a hash index cannot actually be a multi-key index. Now we talk of something called hashed indexes. So the hashing function does the following. What it's going to do is it's going to combine all the embedded documents. So what the hashing function will do, the hashing function combines all the embedded documents and computes hashes for all the field values. However, again, it does not support multi-key indexes. Hashed indexes support sharding. So when we are talking about sharding, so hash-based partitioning is something which is very important and which again is a very relevant thing which the industry does right now. So these indexes use a hashed shard key to shard a collection. This ensures an even distribution of data. So having a hash shard key, what it helps us is, it helps us ensure an even distribution of data. MongoDB uses hashed indexes to support equality queries. However, range queries are something which is not supported. So let me, elaborate this a bit. So when we say it supports sharding, so there are two things which are, said over here. One is hashed shard key, that is hash-based partitioning, and then we are talking about range queries.
Also, if you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who likes to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM. The link in the description box and the comment section should navigate you to the homepage where you can find the complete overview of the program being offered.
Indexes are data structures that can store collections data set in a form that is easy to traverse. Queries are efficiently executed with the help of indexes in MongoDB. Indexes help MongoDB find documents that match the query criteria without performing a collection scan. If a query has an appropriate index, MongoDB uses the index and limits the number of documents it examines. Indexes store field values in the order of the value. The order in which the index entries are made support operations, such as equality matches and range-based queries. MongoDB sorts and returns the results by using the sequential order of the indexes. The indexes of MongoDB are similar to the indexes in any other databases. MongoDB defines the indexes at the collection level for use in any field or subfield. In the next screen, we will discuss index types. MongoDB supports the following index types for querying. Default _ID. Each MongoDB collection contains an index on the default _ID field. If no value is specified for _ID, the language driver or the MongoDB creates an _ID field and provides an object ID value. Single field. For a single field index and sort operation, the sort order of the index keys do not matter. MongoDB can traverse the indexes either in the ascending or descending order. Compound index. For multiple fields, MongoDB supports user-defined indexes, such as compound indexes. The sequential order of fields in a compound index is significant in MongoDB. Multi-key index. To index array data, MongoDB uses multi-key indexes. When indexing a field with an array value, MongoDB makes separate index entries for each array element. Geospatial index. To query geospatial data, MongoDB uses two types of indexes, 2D indexes and 2D sphere indexes. Test indexes. These indexes in MongoDB searches data string in a collection. Hashed indexes. MongoDB supports hash-based sharding and provides hashed indexes. These indexes the hashes of the field value. We will discuss the index types in detail later in the lesson. In the next screen, we will discuss the index properties. MongoDB supports indexes on any document field in a collection. By default, the _ID field in all collections have indexes. Moreover, applications and users add indexes for triggering queries and performing operations. MongoDB supports both single field or multiple field indexes based on the operations the index type performs. The command given on the screen is used to create an index on the item field for the items collection. In the next screen, we will discuss how to create single field indexes on embedded documents. You can index top-level fields within a document. Similarly, you can create indexes within embedded document fields. The structure shown on the screen refers to a document stored in a collection. In the document, the Details field depicts an embedded document that has two embedded fields, ISDN and Publisher. To create an index on the ISDN field and the embedded document called Details, perform the queries shown on the screen. In the next screen, we will discuss compound indexes. MongoDB supports compound indexes to query multiple fields. A compound index contains multiple single-field indexes separated by a comma. The command shown on the screen is an example of a compound index on two fields. This diagram depicts a compound index for the fields user ID and score. The documents are first organized by user ID, and within each user ID, scores are organized in the descending order. The sort order of fields in a compound index is crucial. The documents are first sorted by the item field value, and then, within each item field value, they are further sorted by the stock field values. For a compound index, MongoDB limits the fields to a maximum of 31. In the next screen, we will discuss index prefixes. Index prefixes are created by taking different combination of fields and typically start from the first field. For example, consider the compound index given on the screen. It has item in the ascending order and available in the ascending order as the index prefixes. MongoDB uses a compound index even if the find queries are for index prefixes fields. It uses indexes for querying the item field, the available field, and the sold quantity field. MongoDB cannot efficiently support the query on the item and sold quantity fields by using index prefixes, as it would be like using separate indexes for these fields. The item field is a part of the compound index and the index prefixes. Hence, the item field should be used in the find query of the index. We will discuss sort order in the next screen. In MongoDB, you can use the sort operations to manage the sort order. You can retrieve documents based on the sort order in an index. If you are unable to obtain the documents sorted from an index, the results will get sorted in the memory. Sort operations executed using an index show better performance than those executed without using an index. In addition, sort operations performed without an index gets terminated after exhausting 32 megabytes of memory. Typically, indexes store field references in the ascending or descending sort order. For single field indexes, MongoDB can traverse the index in either direction. Hence, the sort order is not important. However, for compound indexes, the sort order is important because it helps determine if the index can support a sort operation. In the next screen, we will discuss how to ensure that indexes fit in the random access memory, or RAM. When indexing a field containing an array value, MongoDB creates separate index entries for each array component. These multi-key indexes in queries match array elements with documents containing arrays and select them. You can construct multi-key indexes for arrays holding scalar values, such as strings, numbers, and nested documents. To create a multi-key index, you can use the db.collection.createIndex method given on the screen. If the indexed field contains an array, MongoDB automatically decides to either create a multi-key index or not create one. You need not specify the multi-key type explicitly. In the next screen, we will discuss compound multi-key indexes. In compound multi-key indexes, each indexed document can have maximum one indexed field with an array value. If more than one field has an array value, you cannot create a compound multi-key index. An example of a document structure is shown on the screen. In this collection, both the product_ID and retail_ID fields are arrays. Therefore, you cannot create a compound multi-key index. Note that a shard key index and a hashed index cannot be a multi-key index. In the next screen, we will discuss hashed indexes in detail. The hashing function combines all embedded documents and computes hashes for all field values. However, It does not support multi-key indexes. Hashed indexes support sharding. These indexes use a hashed shard key to shard a collection. This ensures an even distribution of data. MongoDB uses hashed indexes to support equality queries. However, range queries are not supported. You cannot create unique or compound index by taking a field whose type is hashed. However, you can create a hashed and non-hashed index for the same field. MongoDB uses the scalar index for range queries. You can create a hashed index using the operation given on the screen. This will create a hashed index for the item's collection on the item field. In the next screen, we will discuss TTL indexes in detail. TTL indexes automatically delete machine-generated data. You can create a TTL index by combining the db.collection.createIndex method with the expire after seconds option on a field whose value is either a date or an array that contains date values. For example, to create a TTL index on the last modified date field of the event log collection, use the operation shown on the screen in the Mongo shell. The TTL background thread runs on both primary and secondary nodes. However, it deletes documents only from the primary node. TTL indexes have the following limitations. They are not supported by compound indexes, which ignores expire after seconds. The _ID field does not support TTL indexes. TTL indexes cannot be created on a capped collection because MongoDB cannot delete documents from a capped collection. It does not allow the createIndex method to change the value of expire after seconds of an existing index. You cannot create a TTL index for a field if a non-TTL index already exists for the same field. If you want to change a non-TTL single field index to a TTL index, first drop the index and recreate the index with the expire after seconds option. In the next screen, we will be discussing creating unique indexes. To create a unique index, use the db.collection.createIndex method and set the unique option to true. For example, to create a unique index on the item field of the items collection, execute the operation shown on the screen in the Mongo shell. By default, unique is false on MongoDB indexes. If you use the unique constraint on the compound index, then MongoDB will enforce uniqueness on the combination of all those fields which were part of the compound key. Unique index and missing field. If the indexed field in a unique index has no value, the index stores a null value for the document. Because of this unique constraint, MongoDB permits only one document without the indexed field. In case there are more than one document with a valueless or missing indexed field, the index build process will fail and will display a duplicate key error. To filter these null values and avoid error, combine the unique constraint with the sparse index. In the next screen, we will discuss sparse indexes.
So here we are now moving into the memory map files. So what is again a memory map file? So a memory map file contains data stored by the operating system in its memory. Memory map files use the mmap system call to store the data. The mmap method maps the file to a region of virtual memory in the CPU. So memory map file are the critical pieces of the mmap v1 storage engine in MongoDB, and that enables MongoDB to access and manipulate fast data, manage and interact with all types of data, assign data files to virtual memory block having a byte for byte conversion. So I guess again, I don't remember whether it was you or someone else. One guy was having a problem. He was installing some version of MongoDB which again wanted him to work with WiredTiger. That is again another type of engine which I'll talk about just moments later. So this is again one internal storage engine, that is mmap v1 storage engine, and again how it internally stores files. It stores files in a memory mapped fashion, which means it will map every file to a region of virtual memory in the RAM in the CPU. C has a node that only access data. Again, you can see a ping over here that only access data is mapped to the memory. There is the data which we have not accessed as of now is something which won't be memory mapped. So then this is something which we have already talked about. Journaling is something I've talked about. Write concern is something I've talked about. Let's again see what this guy has to say. So MongoDB uses write operations before logging into an on-disk journal. MongoDB first performs the change operation in the journal before making any changes to the data. If a MongoDB instance encounters any error or terminates before writing the changes from the journal to the data files, MongoDB can reapply the write operation to maintain a consistent state. If again the data we get is not consistent, a MongoDB instance exits unexpectedly without a journal. You must then run a repair or preferably a resync from a clean member of the replica set. So whenever you see a MongoDB something which is exited not properly, it is the system is crashed. Before you start it again, please make it a point that you repair the DB when you start it. You can do it with using an option called MongoDB --repair DB. That's again the command. So otherwise you would have just opened the command prompt and typed MongoDB. Over here what I'm doing is again I'm typing MongoDB --repair DB, which is again going to repair if there is some locks and all over there. It's going to make sure all of them get cleared and again our MongoDB is up. When journaling is enabled, even if MongoDB stops unexpectedly, the program can recover all the written data to the journal. The recovered data is in a consistent state. By default, the writes lost by MongoDB and the writes that were not made to the journal are made in the last 100 milliseconds. So it means again the chance of myself losing data is again the data which just got written in the last 100 milliseconds, which again is quite a short of a fraction of a second. So if journaling is enabled and if you have sufficient RAM in the system, the entire data set and the entire write working set can reside in the RAM. To enable journaling, start MongoDB with a journal command line option, but again with the 3.0 and above options of MongoDB, versions of MongoDB, by default MongoDB comes with journaling enabled. So when we talk of storage engines, so again a storage engine manages how data is stored on a disk. A database supports multiple storage engines. Each engine performs specific workloads as follows. Again, what those specific workloads can be. Again, this can be manage read heavy operations. Again, it can be higher throughput again for write operations. So again, there can be two kinds of application. Again, read extensive and the write extensive. Again, both of them who handles again it's the storage engine. So again, as you can see, with multiple storage engine options available, you can choose one that best suits your application. So here we have the first engine, which is mmap Weave storage engine. So again, mmap Weave storage engine is based on memory mapped files that manages high volume operations such as inserts, reads, and in-place updates. Again, it is the default storage engine in MongoDB 3.0 and all the previous versions. To ensure that all the dataset modifications are stored on the disk, MongoDB records all the modifications in a journal. It writes to the disk more frequently than it writes all the data files, which again makes sense that I just closed out all the options of me losing some data. The journal lets MongoDB recover data from the data files after MongoDB instance exits without making all the changes. So that is why we'll be able to back up the data even if the database goes off. And the second engine we have is the Wired Tiger storage engine. Again, what it again entails is in MongoDB version 3.0 and above, an additional storage engine Wired Tiger is also available. The features of the Wired Tiger storage engine are as follows. Again, it's optionally available in the 64-bit build of MongoDB version 3.0. Again, what it does it supports high volumes of read, insert, and more complex update workloads. All write operations occur within the context of a document level lock. So what again Wired Tiger brings in document level locking. It means if I want to update parallelly multiple documents in a collection, I can do that with document level locks. If I am updating the document which is by the name Demalya, again a lock will be done on top of that so that no one else can update that particular thing. So that is something which came in with the Wired Tiger. So again it uses a write ahead transaction log in combination with the various checkpoints, which again helps in recovery of the data. So using Wired Tiger, MongoDB commits a checkpoint to the disk either every 30 seconds, either every 60 seconds, or when there are only 2 GB of data to write. So either whichever is less, either 2 GB of data or again 60 seconds, it will write a checkpoint to the disk. The checkpoint thresholds are configurable and all data files between and even the checkpoints are always valid. So this is something which we can change. I can make the 60 as 30, 60 as 90 according to the requirement of my MongoDB application. The white tiger journal persists all data modifications between the checkpoints. If MongoDB exits between the checkpoints, again it enables the journal to replay all the data modified since the last checkpoint when it was done. So then along with that, white tiger also allows a compression support. If I want to compress a document, a collection, a database, again it provides us an option to do that as well. So it again uses 2 types of compressions for collections and indexes. One is the prefix. It again uses for all the indexes in the white tiger engine. So again, I guess in your system, what is running is a white tiger. With the 3.2, it is becoming, it is coming with as the default storage engine we have. So again, block, all collections in white tiger use block compression combined with the snappy algorithm. So snappy compression is also something which you would have seen in a Hive, when you would have talked of Hadoop. So the way snappy can be used in Hadoop, again, the snappy compression comes into picture in Mongo with the help of this white tiger storage engine. So you can modify the default compression settings for all collections and indexes. During collection and index creation, you can configure the compressions on per collection and per index basis. So again, when I create a collection, I can better specify whether I would really want some compression technique to be used or not. The default compression settings balance storage efficiency and processing requirements for most workloads. So again, as I say, any analytics engine is a mix of 2 things. One is storage and one is performance. So again, the current settings, whichever are, again, that's a mix and match of both. But again, if there is something which you want specifically more on, it is something which is configurable. Then we look at, the power of 2 size allocations. So this is again an important concept coming in. Very important. I would like, you to specifically focus over here. So again, in earlier versions, which was, map even and all, there was by default a thing called padding. What is padding? Now again, I'm not writing anything. Please, you can close your eyes and hear what I say. Suppose, I have stored a document in a collection. Suppose it is 10 MB long. It is 10 MB long. Now, MongoDB has allocated a storage for this 10 MB in its database. Now, I make an update to this document and the update makes this 10 MB document as 14 MB. Please understand. Now, when it first got created and when I updated it, there was good amount of time between that, say 15 days. Within 15 days, a lot of data has come in. So now what is happening is, I have not allocated my storage for the document as 14 MB. It's only 10. So now my 10 MB of the document will reside somewhere else. 4 MB will have to reside somewhere else. Or I will have to move the document somewhere else which fits the size. So this will be an additional overhead to the system. For this purpose, what Mongo used to do, Mongo used to implement a padding factor. So whenever it's storing something, it used to keep some factor internally, which the framework decides that okay, if it's 10 MB, it is doing this read operation, this write operation. Let me put a padding factor of 1.2, which will again make the 10 MB of storage to say 12 MB. So always some padding is required so that again the document is then moved to some other location, which again will be a overhead. So that was something which was by default with mmap v1. What white tiger gave was, if again you have a collection in which all you do is insert, you never update. You don't have a chance of increasing the document size of a collection. You can just decrease or say no to that padding factor, which will again save some good space of yours. So that's what is written on the slides. Now we'll go to the slides. So again, power of 2 size allocation mean again the size which can be allocated to any document will again all the time will be 2 raised power of. So MongoDB version 3.0 uses the power of 2 size allocation as the default record allocation strategy for the mmap v1 storage engine. Each record has a size in bytes that is a power of 2. For example, 32, 64, 128, 256, 512, and 2 MB. For documents larger than 2 MB, the allocation is rounded up to the nearest multiple of 2 MB. The power of 2 size allocation strategy has the following key properties. It can reuse freed records and reduce fragmentation. That's what I just told you. Quantizing record allocation sizes and a fixed set of values ensures that an insert will fit into the free space available due to deletion or relocation of some earlier documents. That is, it will reduce the fragmentation. Again, the second thing can reduce moves. How again? The added padding space gives the document scope to grow without requiring a move. In addition to saving the cost of moving, this results in few updates being made. So that's what I was saying. That's what the new thing which comes in. No padding allocation strategy. So for some collections, the workloads that consist of insert only or document update operations do not increase or change the document sizes. For such workloads, you can disable the power of two allocation using the following two commands. One is the call mod command with the no padding flag, and one is again when I create a collection, I specifically give the no padding option as a parameter to that. I specifically say that create this collection, and again, please don't put any padding because highly improbable, highly rare that I will make an update which will make the document size grow. So prior to version 3.0, MongoDB used an allocation strategy that included a dynamically calculated padding as a factor of the document size. We didn't have actually a policy of having a no padding allocation. So diagnosing performance issues, so how we can do that? So degraded performance in MongoDB is typically a function that depicts a relationship among the following. Why can a performance degrade? The quantity of data stored in the database may be very large. Again, it can be a factor of what is the amount of available system RAM, the number of connections which are making to the database, and again, it can be the amount of time the database spends in the locked state. All of them can be, again, a factor in, again, the degraded performance in Mongo. The performance issues are also the results of inadequate or inappropriate indexing strategies, and again it can be a result of poor schema design patterns as well. So again, following are some of the causes of performance degradation in MongoDB. So left hand side we'll study first, that is the locks. So again, locks ensure dataset consistency, that if one is using other cannot update it. Lock related slowdowns are irregular. To know if a lock affects your database performance, how we can do that? Review the data in the global lock section of the server status output. So again, how again an administrator, MongoDB administrator can come to know whether locks is something which is having a serious contribution to the degradation of performance. He can again run the server status command. So again, you remember we would have run the server status command I guess 1 or 2 weeks back, which again gave us a lot of information about how the server is doing. So if again the global lock.current queue.total is consistently high, it means again there are a large number of requests which are waiting for a lock to get released, which again means our performance is getting degraded because of again the lock. This indicates that a possible concurrency issue is affecting a database performance, which again means concurrently more than 2 clients are trying to change one particular document at once. So that was something about locks. Talking about the memory usage, how again it helps. So MongoDB uses memory mapped files to store data. To determine MongoDB's memory usage, again I can do is again the same server status command. I can just check the stat usage metrics of the server status command will give us more input on how again MongoDB is using its memory. If the resident memory exceeds the system memory and there is a significant amount of data on the disk that is not in the RAM, you have exceeded the capacity of a system. So again, please be very important to note over here. RAM is something which is a very important component in MongoDB. So if again the data which you have in the disk is much more than the data you have in your RAM, it means this is something we will have to have a look. So if the map memory is greater than the system memory and operations read data from the virtual memory, then again it will negatively impact the system performance, again causing a lot of concerns. So again, some more causes apart from the locks and the memory which can be is, one is page faults. So occur when MongoDB reads from or writes data to the data files that are not located in its physical memory. The physical memory is exhausted and pages of the physical memory are swapped to the disk. Again, a similar concept page fault as with operating system. So if again I don't have the data in my working set, I'm going to make a page fault from the physical memory, which again will always be an added overhead. Page fault counters in MongoDB may increase because of poor performance and large data set access. Increase the RAM in MongoDB or again deploy a shard to reduce the page fault occurrences. The next thing which can actually cause a performance to degrade is again number of connections. If the number of connections between the application layer and the database is too high, it results in performance irregularities. If the number of requests is high because of the number of numerous concurrent applications interacting, take the following actions. Again, for read heavy applications, increase the replica set size and distribute read operations to secondary members. This is important. I would seriously want you to focus over here. For read-heavy applications, increase the replica set size and distribute the read operations to secondary members. It means don't make the read from primary. Have a separate node where all the reads will happen. So that will ensure that you don't have too much of trouble in your read-heavy applications. For write-heavy applications, again, what we can do is we can deploy sharding and again distribute whatever data we have among the different MongoDB instances in the Mongo set. Now again, talking of again how to optimize better our MongoDB. So many factors can affect the database performance and responsiveness. The following techniques are used for evaluating the operational performance of MongoDB. And what again are those? One is database profiler. So used to identify the performance characteristic of each operation against the database. One is against cap collections. So again, cap collections keep the documents in a proper order even without using the use of an index. And then is the $natural order. So again, if you want to return the documents in the order they exist on the disk and return solid operations, I can use the $natural. So again, as a recommendation, we should use all the three to have better, our MongoDB optimized in this case. Configure tag sets for replica set. So again, you can configure tag sets in a replica set using the following methods. So what we can actually do is, so db.currentTop will give us, information about this. So use this method to evaluate MongoDB operations. This is something which we've already done. This method reports the current operations running on a MongoDB instance. So I am very sure you remember when we did that. And then is again the second step also something which we've already done before. So you will see a repetition, quite a repetition in this particular module. So cursor.explain and db.collection.explain. So again, we can get the execution order with this command. So use these explain methods to evaluate a query performance, such as the index MongoDB selects to fulfill a query and its execution statistics. You can run the methods in the following three modes to control the amount of information returned. Again, I can use as a parameter query planner, execution stats, and all plans execution. All three of them will give different information about how the query which you want to run is running. So I guess at that time we would have ran the execution stats command than we did it earlier. So again, some more things, how again basic things which again even if we don't study that should be fine, but still we'll go through once. So again, how we can optimize better query performance. Again, same as you would have done in the MySQL or the MS SQL Server or the Oracle. Again, create indexes to support queries. For commonly issued queries, create indexes for quick returns. To search for multiple fields, create a compound index for the query. Limit query results to reduce network demand. So again, use the limit method to reduce the demand for network resources. Again, I'm just emitting out my 10 records. Use projections to return only necessary data. So again, over here, it is recommending views. If you don't want the user to see everything, again, why actually make him see everything? Just give the projection, which will again lessen the data which we need to give to the console. Use $hint to select a particular index. Again, use the hint method on queries where you must select the fields included in several indexes to perform performance testing. So again, if we want specifically some particular query to run in a fashion with some particular index, again, I can specify with $hint. And again, I can use the increment operator to perform operations server side. So again, use the $ink operator to increment or decrement values in documents if again the field is a type number. So monitoring strategies for MongoDB. So monitoring is a critical component of database administration. The following three strategies are used for collecting data and monitoring a MongoDB instance. Number one, utilities. So again, distributed with MongoDB that provides real-time reporting of database activities. Our MongoStart will come inside this. Database commands. So again, return statistics regarding the current database state with great reliability. Again, server status will come inside this. .explain will come inside this. And then again, we have something called MMS monitoring, which is again, it again collects data from the running MongoDB deployments and again provides visualization and alerts based on that data. So MMS is MongoDB monitoring service. So it's again a holistic system which will again create some visualization and alert you on what exactly is happening on the system. So on the note, we can see monitoring strategies are complementary and can help answer different questions and are useful in different contexts. So here we are talking about the first one, which is again MongoDB utilities. So MongoDB includes a number of utilities that quickly return statistics about the performance an activity of an instance. So these activities or utilities are as follows. So MongoStat, again what MongoStat will do, again it captures and returns the counts of database operations by type, helps understand the distribution of operation types, and informs capacity planning. So that's something which MongoStat does. And again what MongoTop does, so it again tracks the current read and write activities of a MongoDB instance. How is the write operation activity happening? How is the write operation activity happening? It again reports activity statistics on per collection basis. It enables checking whether database activity matches your expectations or not. And again the third one, we have HTTP console. It again helps receive diagnostic and monitoring information in a simple web page, accessible from localhost, again whichever port number you're running on. If locally running MongoDB is using the default port 27017, again we can access it from the port HTTP localhost 28017. So again what we want to say over here is, it's again similarly as we had in the Hadoop name node UI map reduce UI, we can even do that over here. MongoDB uses the following commands that report the state of the database. db.currentTop helps identify the in-progress operations of a database instance. Server status returns an overview of the database status. Again, does not impact the MongoDB performance. DB stats again returns a document that addresses the storage usage and the data volumes. Again, we have the call stats, provide statistics such as the number of documents, size of collections, and hard disk utilizations per collection. How are the collections doing? A replica set gets status. It is same as rs.status, which again provides details of the state and configuration of the replica set and statistics about its members. And then we have something called Ganglia MongoDB. So again, there are two tools, Ganglia and Nagios. Both of them have capability to get connected with the cluster and give information about the cluster, to monitor the cluster. So Ganglia MongoDB, another command which again allows viewing a replica set information such as memory usage, B-tree statistics, master slave status over here. So again, MTOP, MUnine, and Nagios are the additional tools which again used to check the server statistics and the scripts. So Ganglia MongoDB is something which internally it gives. Nagios again we will have to integrate it manually to ensure things happen. So I guess most of these commands we have already run. We don't need to run these commands. Moving to the next slide, it is MMS, that is MongoDB Management Service, and what it talks about is, so MMS is a cloud service that helps monitor, backup, and scale MongoDB on the infrastructure of your choice. You can monitor more than 100 system metrics and get custom alerts before your system starts degrading. So again, as you can see, we can do that. So you can create your own alerts and integrate monitoring with the tools which you already use. So again, how we can make the data backup strategy in MongoDB? Again, as I told you, MongoDump, MongoRestore will come into the picture. So when you deploy MongoDB in production, you should have a strategy for capturing and restoring backups to prepare for the data loss events. You can perform a backup of MongoDB clusters in the following way. Backup by copying the underlying data files. Backup a database with MongoDump. Use the MMS cloud backup. So most of the time what we do is we back up a database with MongoDump. But again, we will see all of them one by one what they again mean. So you can create a backup for MongoDB by copying its underlying data files. If the volume where MongoDB stores data files supports point-in-time snapshots, you can use them to create backups. The mechanics of snapshots depend on the underlying storage system. On a Linux computer, the logical volume manager, that is the LVM manager, can create a snapshot. To get an appropriate snapshot, we need to do the following. On a running MongoDB process, enable the journaling. So again, in the MongoDB version 3.0 and above, it is already enabled. The journal must reside in the same logical volume as the other MongoDB data files reside. If again journaling is not enabled, snapshot is something which may not be consistent or valid. So on a sharded cluster, we would again first disable the balancer and then capture a snapshot from every shard and config server. Again, why balancer has to be disabled? Because again, it should not happen that one of the chunks is moving from one shard to other. So again, we need to take the exact snapshot. So we'll disable the balancer, take the snapshot for every shard and the config server. If your storage system does not support snapshots, copy the files directly using the copy command in the Linux, rsync, or a similar tool. Backups created by copying the underlying data do not support point-in-time recovery for the replica sets, and again are too difficult to manage for large sharded clusters. These backups are huge, and it's something which is not in general frequently done in the industry. What is done is this: backup in MongoDB. The tool for backing up small MongoDB deployments are MongoDump. So what again MongoDump does, reads data from a Mongo database and creates BSON files. So internally it creates BSON files which does this. MongoDump does not capture the contents of the local database, it only captures the documents which are there in the database. And again, this utility called Mongo Restore, what it's going to do, operate against the running MongoDB process, rebuild the indexes after restoring the data. When connected to the MongoDB instance, MongoDump can adversely affect the MongoDB performance. If the data volume is larger than the available system memory, then the queries will push the working set out of memory, making your system get slow. To mitigate the impact of MongoDump on the performance of the replica set, use MongoDump to capture backups from a secondary member of the replica set, which makes all the sense. Alternatively, you can shut down a secondary and use MongoDump with the data files directly. That would not impact the primary, the read and the write efficiency. If you shut down a secondary to capture data with MongoDump, ensure that the operation completes before its oplog is unable to replicate from the primary again. To restore a point-in-time backup created with oplog, use Mongo Restore with the oplog replay option, which will again get the backup restored from a point in time. Then we have something called fsync and lock. So I can ensure that when some part of the data is getting copied from one database to other, we put a lock on the database, which again ensures things happen perfectly fine. So MongoDB and Mongo Restore allows you to perform data backups without shutting down the MongoDB server. We are not shutting down anything. We can just dump it. We can just restore it. Functions of the fsync command are, it allows the copying of the data directory of a running MongoDB server without any risk of corruption, prevents any further writes to the database until the server is locked. How we can again make that is, we can make ourselves shift to the database, that is use admin, and then again run a command, db.run command, fsync is true, and again lock is true. So again, this will ensure that the server only gets unlocked when again the copy is finished. To unlock the database, use the command given below, db.$cmd.sys.unlock.find1, which is gonna unlock the DB. It allows a flexible backup without shutting down the server or sacrificing the point-in-time nature of the backup. One more way of backing up the software is from MongoDB Ops Manager backup software. So MongoDB Ops Manager is a service that allows you to manage, monitor, and backup MongoDB infrastructure. Ops Manager provides the following services. One is Ops. What is Ops? Provide scheduled snapshots and point-in-time recovery of MongoDB replica sets and sharded clusters. This backup creates snapshot of the standalones that are run as single-member replica sets. And again, one is MMS, which we just started some time back, MongoDB Management Service. Again, has a lightweight backup agent that runs within the infrastructure and backs up data from the specified MongoDB processes. So again, two things which I use very frequently. Again, one is the MongoDump Restore, and now with the coming of this Ops Manager, both of these Ops and MMS are also used to back up the data which we have in our current replica sets. Now, talking of the security strategies in MongoDB. So this is again the last topic, in this module. So MongoDB provides various features to maintain a secure deployment. Following are some of the security strategies in MongoDB. So again, one is authentication. So authentication, it means I will need to authenticate that the client who is connecting with the MongoDB is actually the guy who wants to connect. So mechanism for verifying a user and an instance access to MongoDB. Then we have something called authorization, which again controls user or application access to MongoDB instances. Who is authorized to view which all DBs and which all collections. That all will come under authorization. Collection level access control. So again, we can allow scope privileges to specific collections which can access and which cannot access. Network exposure and security discusses potential security risks for decreasing the possible network-based attack vectors for MongoDB. Then we have the security in MongoDB API interfaces, which talks about, again, it reduces and controls potential risks related to MongoDB, JavaScript, HTTP, and REST interfaces. And then we have in general auditing, where again we talk about it all includes the audit server and the client activities for the different MongoDB and the MongoOS instances. So again, when we talk of authentication, authentication can be implemented in MongoDB using three ways. So MongoDB supports the following three authentication mechanisms. One is X.509 certification, one is Kerberos, and one is LDAP. So when we talk of X.509, so this mechanism supports X.509 certificate authentication for use with a secure SSL connection. So again, secure socket layer. It is used for server and membership authentication. When we talk of Kerberos, so that is again an enterprise standard authentication protocol for large client server systems. So that is something which is again industry-wide famous. And then we have LDAP proxy authentication as well, which again the full form of LDAP is lightweight directory access protocol. If you again would have graduated from a computer science, if you have a computer science graduate degree, you would have studied that in a computer networks subject. LDAP is lightweight directory access protocol. So MongoDB Enterprise supports proxy authentication through an LDAP service as well. So again, security is something, authentication is something which they have ensured using these three authentication protocols inside MongoDB. So again, how I can actually ensure authentication in a replica set, where we have primaries, we have secondaries, and we have the clients accessing both of them. To authenticate the members of a single MongoDB deployment to each other, use the key file and X.509 mechanisms. When you use the key file authentication, this also enables the authorization for all the members in a replica set. When running replica sets in sharded clusters in a trusted and networking environment, ensure that the network uses a firewall and a network routing. The network is either a VPN or a wide area network. The network configuration allows every member of the replica set to contact every other member. And again, the key file configuration is done on all the members to permit authentication. So key file configuration is done on all the replica sets, where I copy the public key of one node to all the systems, so that again, when that node contacts with other node, it has the public key through which it is able to connect. So what I do is I generate two keys. One is a public key, one is a private key. I give a public key to all the nodes, which again ensures when the system contacts the guy, it has the public key through which it is authenticating that, okay, this is the guy, I already know I have the public key, he can access me. So now we talk of authentication on sharded clusters. So in sharded clusters, applications authenticate directly to the MongoDB instances, to the MongoS instances, that is the query routers. The shards in the sharded cluster contains credentials allowing clients to authenticate directly to the shards for maintenance functions. Applications and clients connect to the sharded cluster through the MongoS, that we know. Maintenance operations such as cleanup, orphan, compact, and rsconfig require direct connections to the specific shards in the sharded cluster. So again, the request which goes in that internally has an authentication protocol, which again conveys whether it can access the shard or not. To perform these operations with authentication enabled, connect directly to the shard and authenticate as a shard local administrative user. To create a shard local administrative user, connect directly to the shard and create the user. Again, direct connections to the shard should only be for shard specific maintenance and configuration. So basically, whenever the application tries to get in through the MongoS, internally the application level logic need to ensure that it has the proper authentication to reach through all the replica sets which are there in a particular shard. After authentication, we talk of authorization, who all users are authorized to do what all tasks. So here in this case, authorization, we would have also, all of these things would also be there in MS SQL Server and Oracle, where I specify different roles, and again there are different people doing all the roles. There is admin, there is a root, and all those things. So authorization defines a user's access to a system's resource and operations. Key features of MongoDB's authorization are: users are be able to perform only those operations that are required to fulfill their defined job roles. Role-based access control system controls all the users' access and ensures that all the granted access applies as narrowly as possible. Authorization is not enabled by default. When authorization is enabled, MongoDB requires authentication for all the connections. After authorization is enabled, MongoDB controls each user access through its assigned role. Each role consists of a set of privileges, and each privilege consists of actions, a set of operations. So again, similar way the way we have in MS SQL, which all users can access, which all collections, what all operations they can do, whether they can read, whether they can write, they can execute. So MongoDB provides several built-in roles such as the read, write, DBadmin, and the root roles. Users can have several concurrent roles and receive all the privileges of the rest. And then we have in the end, end-to-end auditing for compliance, what it again tells. And MongoDB administrator needs to implement security policies to control the activities in a system. Auditing enables the following functions: verify that the implemented security policies are controlling the activities as desired. Retaining the audit information ensures that you have enough information to perform forensic investigation and comply with the regulation and policy that require the audit data which your cluster is handling. The auditing facility allows users to track a system activity for deployments with multiple users and applications. The auditing facility can write audit events to the console, the syslog, a JSON file, or a BSON file as we want. So with this, we come to the end of this module as well, which we talked about, a bit of, authentication, authorization, auditing, a bit of, storage engines, a bit of cap file, a bit of GridFS, and then a bit of journaling, a bit of write concern as well.
MongoDB is a document-based database. The basic idea behind shifting from relational data model to a new data model is to replace the concept of a row with a flexible model, the document. The document-based approach allows embedded documents, arrays, and represents a complex hierarchical relationship using a single record. This is how developers using object-oriented languages want to represent their data. MongoDB is schema-free. The keys used in documents are not predefined or fixed. Without a fixed schema, massive data migrations have become unnecessary. While migrating data to MongoDB, any issues of new or missing keys can be resolved at the application level rather than changing the schema in the database. This offers developers the flexibility of working with evolving data models. The table given on the screen depicts the various SQL terminology and concepts, and the corresponding MongoDB terminology and concepts. In MongoDB, the table and view structure is known as collection. Typically, these collections group documents that are structurally or conceptually similar. MongoDB allows embedding a related document to one another. These documents are used to query related data. The data for a table in MongoDB are distributed among different shards, which is similar to the concept of partition in relational database management systems, or DBMS. After grouping structurally similar documents into collection, MongoDB groups different collections into databases. For instance, a single instance of MongoDB is capable of hosting multiple independent databases. Ideally, you should store data related to a single application at one database. You need separate databases when storing multiple application or users' data on the same MongoDB server. The data model in MongoDB is document-based. Although documents provide rich structure, they need not conform to any pre-specified schema. In a relational database, rows are stored in a table, and each table has a strictly defined schema that specifies the permitted types and columns. If a row in a table requires an extra field, the entire table needs to be altered. MongoDB, on the other hand, groups documents into collections that do not follow any schema. Each individual document in a collection can have a completely independent structure. In practice, documents in a collection are relatively uniform. For example, if you are creating a collection review_comments for storing review comments given by the customer, then every document in this collection will have fields such as title, tags, comments, and so on. The lack of schema offers many advantages. First, since structure is defined by the application code, not the database, this speeds up initial application development when the schema tends to change frequently. Second, a schema-less model lets you represent data with variable properties. Compared to RDBMS, such as MySQL, which supports two-phase commit, MongoDB only supports a single-phase commit at each document level. A write operation in a single document is considered atomic in MongoDB, even if the operation alters multiple embedded documents. However, the entire operation is not atomic, and other operations may interleave. Some of the key features of MongoDB are as follows. Ad hoc queries. MongoDB allows performing of search functions by field, range queries, and regular expression searches. Queries can return specific document fields and may include user-defined JavaScript functions. Querying. For document retrieval, MongoDB uses rich query language. It also allows you to write any complex condition to retrieve documents. Fast in-place updates. MongoDB allows you to choose write semantics, enable journaling, and thus control the speed and durability. All writes are sent across a Transmission Control Protocol, or TCP socket, and do not require a database response. To get a response, use the special safe mode of the drivers and perform a write. This generates a response acknowledging the receipt of the write with no errors. Server-side JavaScript execution. MongoDB uses JavaScript inquiries and aggregation functions such as MapReduce, which are sent to the database for execution. Capped collections. Capped collections are fixed-size collections supported by MongoDB. These collections maintain insertion order, and once the specified size has been reached, behaves like a circular queue. MongoDB supports other data types while retaining JSON's essential key-value pair characteristic. How values of each type are represented depends on the language used. Following is a list of the commonly supported data types. Null is used to represent both a null value and a non-existent field. For example, field X has null value. Undefined is used in documents. JavaScript has distinct types for null and undefined. For example, field X is undefined. Boolean is used to represent true and false values. For example, field X is a Boolean variable whose value is true. 32-bit integer cannot be represented on the shell. JavaScript supports only 64-bit floating point numbers. Hence, 32-bit integers will be converted to 64-bit. 64-bit integer. The shell cannot represent these and will display them using a special embedded document. 64-bit floating point number. All numbers in the shell must be of this type. Here are a few more data types supported by MongoDB. Maximum value. BSON contains a special data type that represents the largest possible value. The shell does not support this type. Minimum value. BSON contains a special data type that represents the smallest possible value. The shell does not support this type. Object ID. Object ID data type is unique, fast to generate, and ordered. These consist of 12 bytes where the first 4 bytes represent the object ID creation time. String. BSON strings are UTF-8 compliant. Typically, when serializing and deserializing BSON, programming languages convert language strings to UTF-8 format. This allows easy storing of international characters in BSON strings. Symbol. Symbols are not supported by the shell. When the shell gets a symbol from the database, it converts it into a string. Timestamps. BSON offers a special timestamp for internal MongoDB use that is not associated with the regular date type. Note that within a single MongoDB instance, timestamp values are always unique. Date. Date in BSON is a 64-bit integer that denotes the number of milliseconds since the Unix epoch. It can represent a date range of about 290 million years into the past and future. Regular expression. Documents contain JavaScript's regular expression syntax. For example, X is the field whose value contain substring Simplilearn. Following are some more data types supported by MongoDB. Code. Documents can contain JavaScript code. For example, logic inside function. Binary data. It is a string of arbitrary bytes. It cannot be manipulated from the shell. Array. Sets or lists of values can be represented as arrays. Courses is the field whose value is an array. This array holds 3 elements, PMP, Cloud, and MongoDB. Embedded document. Documents can contain entire documents, embedded as values in a parent document. For example, course_duration is the embedded document which has field name MongoDB. The value for this field is 24 hours. The core database server of MongoDB can be run as an executable process called MongoD or MongoDB.exe on Windows. The MongoD process receives a command to run the MongoDB server over a network socket through a custom binary protocol. The data files for a MongoD process are stored by default in the directory /data/db. You can run a MongoD process in several modes. The most common mode is the Replica Set. Typically, Replica Set configurations comprise 2 replicas and an arbiter process that reside on a third server. The auto-sharding architecture of MongoDB consists of MongoD processes configured as per-shard replica sets. It also consists special metadata servers called config servers. In addition, MongoS, a separate routing server, is used to send requests to the appropriate shard. MongoS queries from the application layer and locates the data in the sharded cluster to complete these operations. A MongoS instance is identical to any MongoDB instance. MongoDB tools consist of the following: JavaScript shell, database drivers, and command line tools. The JavaScript shell. The command shell in MongoDB is a JavaScript-based tool. It is used to administer the database and manipulate data. A Mongo executable loads the shell and connects it to a specified MongoD process. In addition to inserting and querying data, the shell allows you to run administrative commands. Database drivers. The MongoDB drivers are easy to use. It provides an application program interface, or API, that matches the syntax of the language used while maintaining uniform interfaces across languages. Tengen, a company behind MongoDB, supports drivers for C, C++, C#, Erlang, Haskell, Java, Perl, PHP, Python, Scala, and Ruby. Command line tools. MongoDB contains the following command line utilities. MongoDump and MongoRestore are standard utilities that help back up and restore a database. MongoDump can save the data and the BSON format of MongoDB, and thus is used for backups only. This tool is used for hot backups and can be restored with MongoRestore easily. MongoExport and MongoImport are used to export and import JSON, comma-separated value, or CSV, and tab-separated value, or TSV, data. These tools help you get data in widely supported formats. You can use MongoImport for initial imports of large datasets. However, you need to adjust the data models for best results. In such a case, you can use a custom script to easily import the data through one of the drivers. MongoSniff is a wire sniffing tool used for viewing operations sent to the database. This tool translates the BSON that is transmitted to human-readable shell statements. MongoStat is similar to IOStat. MongoStat provides helpful statistics, including the number of operations per second. For example, inserts, queries, updates, deletes, and so on. It also provides information such as the amount of virtual memory allocated and the number of connections to the server. This demo will show the steps to install MongoDB on Linux. In this demo, you will learn how to install MongoDB on Linux machine. First, download the latest MongoDB binary for Linux platform. To download, type the command shown on the screen. After the MongoDB binary is downloaded, untar it by executing the command shown on the screen. Next, create a directory /MongoDB by executing the command make directory -p/MongoDB. Next, copy the untarred directory by executing command shown on the screen. To run MongoDB from anywhere in Linux, you need to add MongoDB installation path in the .bashrc file. To do so, execute the command vi /root/.bashrc. Next, type the two commands given on the screen. Note that your .bashrc file location may be different based on your username and profile. Reload the environment variable by executing the command source/root/.bashrc. Next, execute the command echo $MongoDB_home to verify whether the environment variable MongoDB_home has been set or not. This concludes the demo on installing MongoDB on Linux computer. This demo will show the steps to install MongoDB on a Windows computer. In this demo, you will learn how to install MongoDB on a Windows computer. MongoDB for Windows runs only on Windows Server 2008 R2, Windows Vista, or the later versions. The .msi installer includes all software dependencies. If you have an older version of MongoDB installed on your computer, the .msi file will automatically upgrade it to the latest version. To install, first go to the site given on the screen. In the Download and Run MongoDB page, scroll down and click Download to MSI, and then click Run. Once the MSI file is downloaded, the installation wizard opens automatically. Next, follow the default options on the wizard to install MongoDB. This concludes the demo on installing MongoDB on a Windows computer. This demo will show the steps to start MongoDB on Linux. In this demo, you will learn how to run the MongoD server and the Mongo shell on Linux. To start the MongoD server, type MongoD in the command prompt. The MongoD script file is in the /bin directory of your MongoD home path. Once MongoD server starts running, open another terminal. To open the Mongo shell, type Mongo in the second terminal. In the Mongo shell, perform the MongoDB insert operation by executing the command given on the screen. To check whether document was inserted, use the find method on Courses collection. This concludes the demo on starting MongoDB on Linux. This demo will show the steps to start MongoDB on Windows. In this demo, you will learn how to run MongoDB Server and Mongo Shell on Windows machine. To begin, navigate to the path C:/program files/MongoDB/server/3.0/bin. To start the MongoDB server, double-click MongoDB.exe. Once the MongoDB server starts running, open another command prompt to open the MongoDB shell. To open the Mongo shell, double-click the mongo.exe in the same directory. To perform the insert operation in the Mongo shell, execute the command given on the screen. To check whether the document was inserted, execute the command db.courses.find.
Also, if you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who likes to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM. The link in the description box and the comment section should navigate you to the homepage where you can find the complete overview of the program being offered.
So first of all, we'll look into how Java and Mongo interact. So again, if you're aware of Java, this is something which will be very easy. Again, the same Mongo thing which we did, how we can interact with Java with this DB. And then we'll talk about how Node.js can interact with Mongo. Both of them pretty simple. And after we talk about that, we'll look into some of the admin features. And when I see this is relatively very easy. Some other utilities like Mongo dump, we have Mongo restore, we have Mongo stats, we have Mongo top. Some of the utilities apart from what we've already started, we'll have a look. So again, Mongo dump used to dump a database into our DB. Mongo restore, again, if you want to bring back any DB which you had already dumped, we can use the Mongo restore ability. Mongo stats is used to visualize, see the statistics, how the cluster is doing. And again, Mongo top will give me which write and read operation is actually taking a lot of time, and which of those operations which are are being done very easily. So again, that is what here we'll also see some part of how the authorization, authentication, and security is something which Mongo takes care of. So I feel this will not take a lot of time, and this as well should be pretty easy to go with. So that is what the agenda for today's class will be. So again, MongoDB drivers and the client libraries. So applications communicate with MongoDB through client libraries or drivers that handle all the interactions with the database in a language that is appropriate and sensible. The following languages again can be used for the communication again in all of them, be the JavaScript, be the Python, be the Ruby, be the Perl, be the Java. All of them can internally be used to communicate with MongoDB. So let's again see how we can actually develop a Java application with MongoDB. So again, to install the Java driver, what we can actually do, perform the following steps. Download the jar from the link given below. That is the GitHub lib from where we can download the Mongo Java driver. The step second will be, again, add the jar to your class path. The Java classes you need to use in a normal application are in the com.mongodb and again the com.mongodb.gridfs packages. So these are the two packages which you will require to again interact with the Mongo database. The jar file contains a number of other packages as well apart from these two. You need these packages only to either modify the driver's internal functionality or again extends its functionality. So again, I guess as you are pretty comfortable with Hadoop as well, similarly Hadoop has the HDFS API which it exposes, and in that what we do is we create a configuration object. In the configuration object we set the property fs.default.name, which again internally caters to the name node IP address, and then what we do is we create a file system instance object, and again pass that configuration as a parameter to that. So again, in the end, the file system is able to know where the name node is running, and that is how internally HDFS API allows operations to be done on top of the Hadoop. Similarly, again, this as well is there. So again, how to connect to Mongo using a Java program. So to create a normal Java application, so again what we need to do is we need to create a new Java project in Eclipse and add the MongoDB Java driver into its build in the class path. So again, we'll need to set the environment variables. Once that is done, the Java driver of the MongoDB provides the com.mongodb.mongo class to connect to the MongoDB server. To establish a connection, create a new Mongo object and pass the IP address and port number of the MongoDB server as a parameter as shown in the code below. So this is something which is exactly similar to how even Hadoop used to do work. So again, you can see in the top we've imported the packages, and then I'm making a class whose name is item search. I'm trying to search for an item in the collection, and again I have my main method, and the main method what I do, I have made a Mongo client object, and what I'm doing is I'm just passing that the server details over there, that it's my system, and again the port number is 27017. After that I'm making a DB object, and again passing that test. So test is the database over here. We're passing the database as a parameter to the DB object, and after that we have a collection. We have a class called DB collection. I'm making an object of that with the names items, and I'm again just saying the db.getCollection the item. So it'll connect to the test database. So again, what is happening is the first line, it's contacting with the server, which is again up on the local host 27017. After that, it is connecting with the test database. After that, it's just getting the details of the items collection in that particular database. So again, what we will see is both the Java and the Node.js. So we will see how to do a CRUD operation from Java, how to do a CRUD operation from Node.js. So again, it'll include how to create a thing, how to insert things, how to update things, and again then how to delete things from that. So let's see how we can actually create a collection from again the Java program. So you can create a collection from a Java program using the create collection method of the com.mongodb.db class. So that's again from the package we imported. A DB object instance is created from the return object of the Mongo client.getDB method or function. So you can see in the main method, it is just explaining what actually is doing. So first of all, the Mongo client, again, I pass on the server details, that is the localhost 27017. Then I connect to the database, as I told you that I've connected to the database, which is test. And after that, I have made a object of the DB collection, and then I'm just saying db.createCollection. So this DB again has the same instance which is connecting with the MongoDB instance. .createCollection, I again pass my call as the name of the collection which I want to pass, and the second parameter I pass is null. Then again, I just write a catch function as well, which again says if again by chance it's not able to create one, it should be able to pass on the message to the terminal. So once again we have the collection created. What I can actually have a look at is how I can insert a document into a collection which I just created. So again, two things I've seen right now. First of all, again, a Mongo client, I just pass the localhost 27017. After that, what I do is I just connect to the test DB. After I connect to the test DB, I can actually look into any collection which I already have. We looked at the items, and again, if you want to create one, I can just db.createCollection, the same command which you used to use Mongo, I can use, and again make a collection of our own. So after the collection now has been made, let's see how we can actually insert documents from a Java program. So again, quite simple. So documents in Java must be instances of the org.bson.db object. A document can be created in multiple ways in Java. However, the simplest way is to create one using the com.mongodb.basicDB object class. So that's again the class already which MongoDB supports, which allows us to easily insert documents in a collection in MongoDB. So to create a document that is represented by the shell as item book, sole quantity 500, again the command which has to be used is something which you can see on the screen. I've made a basic DB object doc is the object of the basic DB object class. I'm initializing it. After that, I'm just doing doc.put. I'm just specifying the key value which I want in that particular collection. So again, the similar way how we used to do in Mongo, just programmatically, I'm just entering things into my collection. So insert documents using Java code example, what we just saw. So create an instance of the DB collection object by calling the get collection method of the DB object. After that, what we need to do, create basic DB object to represent the JSON document in the Java code. Then we can do is, we can call the append method to set the values for all the fields that need to be populated. Again, we can just call the insert method of the DB collection after the basic DB object actually gets initialized. So easily we'll be able to insert documents into a collection with the help of a Java program. So the demos, I guess, what we can do is you can try that out on your end, and then actually you can get back to me and I'll be able to help you out on that, because this will actually consume a lot of time. And I guess this is pretty simple. Again, we know the concept is that we need to integrate the Java with the MongoDB. So this is, I guess, something which is definitely doable. You can try it out at your end, and I guess I'll be there at your disposal to help you if you found any problems in the same. So right now, again, just to summarize what we just did, again, I just made sure that my connection happens to the local host. I connect with the test DB. After connecting with the test DB, all I've done is I've looked for a collection, then I've created a collection, and now I've inserted into a collection using the basic DB object class given in the package. Now what I want to do, I want to update documents using the Java code. How I can look into that? So again, the way we use db.collection.create, db.collection.insert, the same manner, db.collection.update, the same thing being used over here. So the db.collection.update method is used to update an existing document in a collection. In the code given on the screen, the DB cursor object is used to iterate through the list of documents in the while loop and update each document by inserting the field like with its value as 100. So again, the same way how we used to do things in a normal MongoDB command prompt, which you see over here, we made a class by the name update documents. I have the main method over there. And again, in the try block, what I'm actually running is I've made an object of the DB collection class. Again, I just get the collection items over there, or get the collection items into that. Once I have the items collection with me, I'm making an object of the DB cursor, which will again return a cursor, because again, my thing is collection.find. So please, again, I hope this is something which is very easily understandable, that COLL call now has the items collection. It returns a cursor. Again, when I do a collection.find, internally what gets fired is db.items.find. And again, I told you, we already know that db.items.find will internally return a cursor, which again iterates through all the documents in a particular collection. So now cursor again has that cursor which we can iterate. Then I write the while loop where while cursor dot has next. It means while there is a document in the collection, all I can write is, again, I make a DB object, another object by the name update document, and I just do a cursor dot next. So it moves to the first document, and there I can just write update document dot put. Again, likes is something as 100. So again, 200 will be something which will be set to the like key. And then I can do is COLL again, please remember this is the collection which is items. I can just update the collection COLL.update. I can give the first parameter as null and the second parameter as update. Null will keep whatever was earlier into the document, and the next parameter will again add whatever key values I've set into the document. Now we've seen how to create it, how to insert it, how to update it. Now again, the deleting thing, again, very simple, the way we used to do it over there. Similar way, there we used to have a thing called db.items.remove. Here we have a thing called, again, collection.remove. So again, COLL again will be an object of a class, which will again get the collection. So here what we see is we have made a public class delete document. What we again do is we make a main method. In the main method, again, what we do is we have a try block. Again, the same old thing which we were doing even from the previous slides. I make a DB collection object where I get the collection. So here, please see COLL has the my call collection in it. Then I just did system.println collection my call selected successfully. It means I have the my call collection with me right now. Then after that, what I can do, I have made an object of DB object class. Again, what I'm doing is call.find one, get me one document in that particular collection. Once you get that, what you can do is call.remove my doc, whatever document you just got with the find one thing, it's going to remove that. And then what I can do is I can just do db cursor is equal to call.find. So it'll again get me all the records which are there in the present. So that was something using, how we can actually make, Java interact with, MongoDB and again have the CRUD operations done. So now again, GridFS is something which we looked at, yesterday. Now again, if we want to do that, with Java. So again, to store images, what we can do below is, so again, please use the code given below. Please see the code. I made a class called save image. If I want to save an image in my MongoDB using Java, what I need to do, again, I have a main function. Again, in the try block, what I have is, I have connected to a Mongo system, which is running on the port, which is running on the IP address 192.168.133.128. And once it is connected, again, I'm just getting the DB, which DB I need to connect to, that is the image database 1. After that, what I'm doing is, again, we can do both of these things. You can see over here, the commented things again the same thing, which it connects to the test database. It's again just gets to the image database. So both of these things, one of these objects we can make and actually get that thing done. So in this, I am connecting to the image database and I'm storing that particular thing into the test collection. So that's the collection we have got. After that, what I do is I again make a string object, new file name, give that name a GridFS Java image. Then for that, I will have to create a file as well. So again, I'm storing an image, a file has to be created by the name GridFS Java image. But again, where that file actually has to reside, it has to reside in the location which I just specified in the parameter of the file object. So again, that creates internally a photo namespace. Once that is something which is done, how to create a photo namespace is something which will, the below commands will actually guide us how to make a photo namespace. So that is done by again using the GridFS class. So that's again the GridFS API which it exposes. I'll use the GridFS class. I make an object of that is GFS photo. Again, the parameter I just pass the DB. So DB is coming from the top, you see, image database 1, and again the photo. So photo is something, the new namespace which I will be generating, where the photos will get stored. Then again, we have a class in the GridFS API by the name GridFS input file. I again create an object of it, and again I create a file, and in that file I gave the parameter image file. You can see image file in the top, where it is again given the parameter C butterfly JPG. That here I want to create a file. So here the file will get created, and after that, once it is created, the same object GFS file, I'm just setting the file name as the file name which is specified over there, which is GridFS Java image. So a new file will be generated with the name as GridFS Java image. After that, what I can do is I can just save the image file into MongoDB by writing the command, invoking the function save, which is again given in the GridFS API. So GFS file that save ultimately will save that image of whatever thing I want to store into my photo namespace in the text collection in the image database 1. So again, once I've stored my things into the GridFS using GridFS API, how I can actually retrieve those images back. So to retrieve DB cursor objects having reference to the file stored in GridFS, we can use the code below. So what I do is, again, I make a cursor object of a DB cursor class. What I do is, I do a GFS photo.getFileList. It's going to return a cursor. So now my cursor CUR has again the list of all the files I have. What I do is I just iterate through the while loop. While cursor.hasNext, please keep on printing out the cursor.next. Again, I'll keep on getting the images from my GridFS right there into my screen. So after that, again, GridFS DB file image for output is equal to GFS photo.find1, again the new find name. So again, just before what the file we have stored in our collection, that was again by the name. So again, the same file if I want to retrieve, again what I've done is I'm just invoking the function find1, and in the find1 I'm just passing the file name which properly I would specifically search for. So that's how I'm going to retrieve any images using the GridFS API in MongoDB. So again, I've saved an image, I have retrieved an image, again I would remove an image. Again, the same way they used to have, our command prompt used to have a remove method, the Java normally used to have a remove method. Similarly, GridFS API provides a remove method. All I have to do is, again, GFS photo.remove Again, just give that specific, find one, again, pass the parameter, which particular image you would want to delete, and that file internally will be deleted from the GridFS. So that was something about how again Mongo would connect to Java. Just to again rephrase what I just said. So again, Java and Mongo, how will they interact? All you need to do is just download the jar, which again is the Mongo Java driver. Once I have done that, all I need to do is again simple things. First thing is again how particularly we can create a collection in Java. We could easily see that in the Mongo client thing. We pass the localhost 37017, that is the port number. After that, we connect it to the test. The moment we are into the DB, I can use get collection to get whichever collection. So dot get collection is the method I can use to retrieve whichever collection is in my particular DB. Then we looked at creating a collection using dot create collection method. Then we updated a collection using again a DB basic object. We create an object of that, and with the help of dot put function. So again, something programmatically was very easy. So we set the keys and values to some particular document. So again, the syntax again was dot update document. And then we thought of how can we remove it, dot remove. And then what we saw was if we want to store something using the GridFS API, some image or some video into the Mongo, again how we can do that. So Demale, if this is something which is fine with you, a smiley from your side will communicate to me that we are good with this, and we can move to the next thing, which is Node.js, which is even simpler than what we just saw now. So Node.js will be something which will be pretty similar to even what we do on the command prompt. So let's move further to how Node.js can actually be interacted with the Mongo database. So again, to work with the database, first create a connection. So again, the same old story will again you will see again, but even with more easy because the syntax over here again is more or less on the same lines as what we did on the command prompt. Okay, so I get that. So you have experience in MySQL and MS SQL, so it makes all the sense to make a switch on Mongo because having an experience in the relational database is definitely given advantage because you already understand how the relational world works. And again, now with this on top of that, that definitely is like the best of both the worlds. So I guess that should be fine. So to work with the database, first create a connection. So you can use MongoDB's native Node.js driver to create a connection with the MongoDB server. To install the MongoDB native drivers, first install the MongoDB module by using the npm command, run the command given below. So npm basically is the package which Node.js gives, which internally allows all the classes to be used inside Mongo. So what I do is npm install MongoDB. So NPS is a package manager that provides a central repository for all the custom open source modules for the Node.js and the JavaScript. So I install this package manager, which will gonna help me install all the packages, which again come as modules for the Node.js and the JavaScript inside that. Once that is done, so again what npm is, npm helps manage modules, their versions, their distributions easily. The npm install command is used to install the required module in a project. So again, to work with the database, first create a connection. You can use, so again, this is something which we did. Let's move to the next slide. Yeah. So step one is again, load the MongoDB module using the code given below. So again, what I do is, let's require import the MongoDB native drivers. So what I do is, where MongoDB is, it will require MongoDB. So again, I'm just requesting or importing all the MongoDB native drivers from the npm over here. So once that is done, define the URL you need to connect to. So again, I just specify where URL is equal to, MongoDB is running on which particular server. I specify its localhost 27017 and the DB I want to connect to is test. Step 3 is again connect to the DB. Use the Mongo client's interface connect method to connect to the database. So again, Mongo client's interface has a connect method which I can use, which I'm using over here. And again, the same old story, the URL. There again, I used to pass a Mongo client object, which again had the same thing. Here, I'm just passing that URL, which again now has the server details where it is running to the parameter. And along with that, it passes a function. And what it passes in the function, first parameter is error, and the second parameter is DB. So again, you will see the function which it returns over here. The first parameter always will be an error, and the second parameter always will be the actual thing which I will get, and that will return to the object. So how we can actually do an insert operation using Node.js? So after you have a DB connection ready, you can communicate with the database and perform some basic operations on the Mongo database. When using the MongoDB native driver, you need to ensure that the query function names and the parameters are similar to that of the native MongoDB commands. The query functions take the callback as the last argument. This is something which is important. I just told you just moments back. The query functions take the callback as the last argument. The callback function returns the first argument as an error, and the second argument is a result. So whatever result is, that will be in the second argument. The result is actually the output or the result provided by MongoDB on running these commands. This is something how the insert will happen. To create an items collection and save a few items in it, use the code given below. So again, this has two things. One is the create collection and then is the insert collection. So you can see where collection is equal to db.collection, that is items. So we get the items collection over here. Again, how to create some more users inside that. Again, I just need to, so this is again like the normal JavaScript. So again, where item 1 is equal to, I specify the document, item is book, sold quantity is 500. Similarly, I added some 3 items. Again, these are variables. Again, how to insert them into the collection? All I can do is collection.insert. So again, this collection, please see, this where collection is actually this object over here, this variable over here. Collection.insert, I specify these over here. And again, the second parameter, again, the function, which again has 2 parameters. One is the error and second is the result, which is again will be the insertion of all of these 3 items into my items collection. So in the insert operation, you perform the following steps, what we have just done. I use the db.collection method to get the collection, prepare data to be inserted, that is the variables which I've created, which will be inserted, and then I just insert them into the database. So that was how the insertion used to happen. Now again, insertion is done. How we can actually update it? So update is again simple. Dot update is the thing. And again, one more thing you will see very similar over here is this is exactly the same how the command prompt used to work. So you can update records using the collection.update method. The name and parameters of the update method are similar to that of native MongoDB queries. The code given below updates the document from Node.js. So how to get the collections document? So again, this is something which we just saw in the previous slide. Where collection is equal to db.collection items. So here my collection variable has now the items collection. Then what I do is insert some users. So again, I'm doing collection.update. Again, update that document whose item is pencil. And again, as you can see, I can use the $set variable the same way. I can use this $set operator in the native MongoDB query. And again, I'm saying update that document whose item is pencil. And again, what you need to do is set its availability to false. So again, the second parameter is function, which again has 2 parameters. First is an error, and the second is actually the num, which actually got updated. So then what I'm doing is, if again, what I actually return is error. If the function, what it returns is error, so what you do is console.log, whatever error comes, you just, set it to the console, which is again, I should see that error on the screen. If that is not the case, else if num updated, or if it returns is something which is num updated, what you need to do, you can print it on the log that updated successfully as many documents as many would have got done. And again, if that also doesn't happen, what you need to do is you need to put it like, I couldn't find a document with the actually find criteria, that is any item which has the item as pencil. Exactly the same way how we used to do in native MongoDB query. So again, how to retrieve the documents using Node.js. So again, to retrieve the documents from the MongoDB, trigger the find command on the collection object just as in the MongoDB shell. So again, what we have done is, first of all, get the documents collection. So you can see where collection is equal to db.collection items. So here the collection variable has the items collection. And now what I'm doing is I'm just trying to find records which again have some things. So again, the way I used to do over there, db.orders.find. I used to specify some parameters inside. Same thing I'm doing instead of the db, which again used to connect to the MongoDB instance. I'm using here collection, which internally anyways it's connecting with the db. So collection.find, item is pencil, .toArray. So .toArray is something which is exactly same as .pretty. You used to do a .pretty to see a pretty result. Instead of .pretty, you can also use a .toArray. Both of them will do the same thing. The difference between .toArray and pretty is .toArray will bring all the data into the memory and then show. So it's recommended you always do pretty instead of actually a toArray. Again, it returns 2 things. First parameter is error or the result. So again, if it's an error, give the error to the console. If again, it's actually the result, again, output it, the result along with, output the found along with whatever results we have actually got. And again, if that also doesn't happen, you can just give out in the console that I couldn't find any document which had the criteria which is specified in the find function. Again, how I can actually retrieve documents using a DB cursor. This we again retrieve just by using a simple collection.find method. Again, if I have to use it using a cursor, what I can do is you can use the DB cursor instead of each document, or use toArray to return the full array of all the documents. Here what I'm doing is, again, where collection is equal to db.collection items. My collection variable has the items collection right now. Now what I do is variable cursor is equal to collection.find item is book. You know, every find function returns a cursor. So here that cursor is with cursor. Then what I'm doing is, again, I'm sorting the cursor in a reverse order of item. Again, I'm limiting the results to 10 and I'm skipping 0 results. It means I just want the results to be shown from number 1. So again, now the cursor is with me. I need to iterate on the result which I get. So what I can do is cursor.each. Again, I can give the function error comma doc. So again, I can just do is, again, if we get an error, console printed the error, and again, if that doesn't happen, what you do is on the console you can print it out. Whatever fetched is something which will be printed as such along with doc. So doc will be something, the document which we would have retrieved after the cursor would have gone through the full collection. So that's how, again, if I want to use a cursor to get the documents, this is the way which I can follow. So that what we saw was, we saw again MongoDB with Node.js, again a different approach, the same way how Java did it, but again the syntax would vary here there. So now again there is a very good module inside Node.js as well, which is Mongoose. So what Mongoose helps us do, Mongoose helps us, design the schema in MongoDB. So we'll just see, how Mongoose helps us design the schema in Mongo. So Mongoose.js is a popular library in Node.js that provides a straightforward schema-based solution to model your application data and includes built-in typecasting, validation, query building, and business logic hooks. Using the Mongoose interface features such as automatic connection and a collection pool management, we can easily work with MongoDB. To work with Mongoose, you need to first install the Mongoose module. So again, all I can do is, the way I ran npm install MongoDB. Similarly, npm install Mongoose will help us install the Mongoose module. Once the Mongoose module is up and running, I can set the schema like this. So in the code, you are doing the following things. What you're doing is connecting to the database using the mongoose.connect. So again, I was connecting over there with mongo.connect. Here I'm using the Mongoose module to actually connect to my database. And then what I'm doing is creating a model using the mongoose.model. So again, two methods, mongoose.connect and mongoose.model. Let's see, how the code does it. So again, how to load the Mongoose module in our program. So again, please again correlate with what we studied. Earlier we used to write where MongoDB is equal to require MongoDB. I actually loaded the MongoDB module. Now because I need to load the Mongoose module, I write where Mongoose is equal to require Mongoose. It'll actually load the Mongoose module in our program. Once that is done, we'll connect to the database using the DB server URL. So again, I get mongoose.connect. This is the URL, the server URL, which we used to specify in the Node.js as well. That okay, localhost or whatever 27017. Again, this DB I want to specifically connect to. Once we have connected to the DB as well, we need to define our model for user entity. So user over here, you look at user as a collection. So the way I design a schema for a table, here I will design a schema for a collection. So let's define our model for user entity. This model represents a collection in the database. So we define the possible schema of user document and data types of each field. So again, as you can see over here, where user is equal to mongoose.model. Again, user is something which is of a collection, and again how the documents in my collection is going to look like. See, the name is string, roles is array, age is number. So it will even allow us to store some relational information as well into my DB. This is something which I remember, I guess, I don't know whether you asked it or someone else asked this, that whether we really need to set some, whether we need to tell our Mongo that this thing particular which I'm giving is a string or an integer or something else. So that is something which I can definitely do over here. Or then let's create a new user. So again, how we create a new user. So where user was is equal to new user. And again, what I just did was I did the same thing, use this schema and again give name as modulus admin, age is 42. And again, the roles he has is he's admin, he's a moderator and a user. Once that is something which is done, I can easily add that into my collection. So create a new, so you perform the following action using the code given below. Create a new user object. So you can create as many user objects using the model as desired and modify them. So this user object, see, each object will represent document in the database. Please see this user object, whichever I have created. What is this? This is one document. And it says, so again, see, what will happen is, so Simplilearn only gives you Node.js and Java. Suppose you want to do it with Python. What they will say? No, I don't know Python. I don't. So, okay, you don't know even Node.js. So look at, the similarities between being done all over. Things here, things there will change in the syntax, but the crux will remain the same. The object user one over here, what is actually this? This is an object. And again, same thing is saying is, so you can create as many user objects, means you can create as many collections, as many documents in a collection. And again, each document, each object will represent document in the DB. That's something which I guess is pretty easy and straightforward. Then what I can do is, so I've kept on adding these user objects. Now I need to really save this user using the save method as well. The way you used to have a save and an insert method in the normal native MongoDB querying, same way we have it over here as well. So save the user within the same method. The Mongoose model has many methods available on the entity objects. In this case, you will use the same method to save the document in the database. So again, what we do is, so user1.name is equal to user1.name.to uppercase. It means all I'm doing is I'm trying to update the document which I already had. I had a user1, so again, I'm just checking that can you please convert the name into uppercase. Once again I've done that, I want to see whether the output is correct or not. All I do is console.log user1. So in Java, I used to do system.out.println. In C, I used to do printf. In Python, I used to do print. In Node.js, I use console.log. So these are the syntax changes. Basically, I'm just outputting user1. I should see the updated result. Once that happens, let's save it. User1.save. Again, the function will return two things: error or the user object. If we get an error, print out that error. If we get the user object, again, write it, save successfully, and give the user object over there. That's how, again, I'm going to define a schema using Mongoose. That's how I'm going to insert, update some documents using Mongoose.
And with that, we have reached the end of this session on Advanced MongoDB Full Course. If you have any questions or if you require the resources that we used in this session, like PPT, dataset, code documentation, etc., please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, stay safe, keep learning, and get ahead. Thank you for watching. Stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.